into data science. So what exactly a data scientist going to do, right? So before getting into or before walking you through data preparation, our first module, advanced data preparation, I just want to start with the prescriptive analytics, predictive analytics, and even descriptive analytics. So what exactly meant by descriptive analytics, and what exactly a data scientist going to work on, right? So before looking into all this, I just want to start with a small definition, which is nothing but what is meant by a data, right? So when you're looking into the definition of a particular data, so you can see this. So I have set of, we can say like, what are you doing? So is it a data? For example, here we can see 200, 93, 33, 150, 59, 68, Anil, Vijay, Karthi. In this way, there are different names, so we call it as a data? I don't think so, right? So you have the first quarter, second quarter, third quarter, but which company quarter sales, right? Or what is this numbers, or who are this names? So I want to know what exactly is it. So the exact definition of a data is nothing but set of measurements on set of recorded values. I call it as a data, right? So when we are getting into data scientist, or when you call as a data science, now whatever you are learning it, so the major purpose of a data scientist is we need to grab the insights out of the data. So in case if it required, we need to do certain preparation. So before grabbing the insights, we need to do the data preparation. So based on the data preparation, we choose any of the techniques from predictive analytics like machine learning or deep learning or text mining or time series forecasting, and we try to do the particular, or we try to solve the problem using any of these techniques. This is the basic understanding behind data science. So what exactly a data scientist going to do in his day-to-day activities is, the very first stage of a data scientist is he would be working on collection of data. So he need to work on collection of data. So when we are looking into collection of data is the very first stage. So how exactly he would be collecting the data based on the problem statement. So after collecting the data, so what exactly meant by data is set of measurements on set of recorded values. So when you are getting into a e-commerce company, there is a set of measurements on set of recorded values. So which is nothing but, so it may be customer name, it may be shipping mode, it may be the product you bought, it is the discount of what you availed, and this is something related to your certain thing like your any of the whether the processing, whether it is shipped or not, so all the status. So we call it as, again, set of measurements on set of recorded values. So we call set of measurements, here we have that we call the set of measurements as nothing but columns, and we call the recorded values is nothing but the rows in a particular data set, right? So if you are going with e-commerce, this is the data. If you are getting into finance, the set of measurements, the columns going to be name, so it may be like we can say location, the CIBIL score, salary, so amount of old loan amount, etc. and etc. And number of recorded values going to be the based on the size of the business, so they would be having a huge amount of recorded values. So as a data scientist, I want to collect set of measurements on set of recorded values, which is nothing but a data. So in order to draw various insights, the first thing, I want to draw various insights out of the data, or I want to work on various, we can say like, I want to work on various analytics, is nothing but we call it as pulling out the insights, or we need to work on predictions, or we call it as automation using machine learning, or automation using machine learning, right? So these are the three major things what exactly a data scientist going to work on. But you can ask me, when we are able to do these steps, what is the need of a database and what is the need of your data preparation? It's very simple, and why we need need to go with a particular day, why we need to go with our programming majorly, right? So for this very simple question, let me go back to one of the small illustration I want to give. So we are running a business around 1980, right? We used to do all the data in a book. So where exactly in a book we used to create with a scale, we are able to create various columns. We are able to say the customer name and the product he bought. And with respect to this product, he bought something related to the sales he made. So what is the sales? So for this customer name, for this particular product, this is the price we quoted him and we got this much amount of profit. So in this way, I used to write everything in a book, right? Now the wheel is rotated. Now in this particular book, so my particular friend called me, hey, if you don't mind, can you understand this particular data or the number of customer records which are present in my book, and if you don't mind, can you just build me a model? So what exactly a model is? So in 1980 I'm running a business and I'm having a lower sales situation which is happening. So if you don't mind, so based on the customer name, based on the product, based on their location, and can you tell me which product is highly sold, right? Or can you tell me which location people are buying my products? So based on that, what I would be doing is I would be investing my money on the same product across those locations so that I can utilize less amount of money and I can make more amount of profits, right? It's a very good idea. It's in 1980, I think implementing analytics is great, right? Why? In the sense, even this, whatever the topics you are learning now, they're not new. They are present in the industry since 1950, right? Now why it's got boomed or why it is taking up the shape is only because of the data we are having in our industries. So now I just want to deal with the data. So now in this particular data, when I'm looking into the book, so my particular friend may not be loading the data in a proper way. He may be writing all the time. He may not write the product name. He may miss it. So some cases he may not write the particular sales happened. There may be some null values. So the column names may not be proper, right? So the names may not be written in a proper format, right? So what I need to do, even in order to make a certain analysis on this data with the help of my friend, I want to prepare this data. I want to prepare this book, whatever he provided. Why? In the sense, if I'm not preparing it, so it may lead to wrong analysis. So due to wrong analysis, my friend going to implement a wrong strategy, and due to that he gonna scold me. So the entire thing going to be failure if I fail at data preparation. So data preparation is one of the very important stage in order to do an analysis or in order to do a prediction. So very important stage is data preparation. Now before going into data preparation, so you can ask me one thing, so we can do everything in a manual process or in a mathematical direction, so why you are using programming? What is the need of programming? Very simple. Now in order to make this decision in 1980, I used to calculate, I used to take a book and I used to write a mathematical equation. I'm a mathematician. So probability of buying a particular product based on, so probability of buying a product based on certain brand or based on certain amount of color. So by use, we can calculate it using this equation. So we call this equation as Bayesian equation, I think, which we learned it in our very schooling, Bayesian equation or a theorem. Right? So with the help of this equation, we can say what is the probability of buying a product, so based on its color, or what is the probability of buying a product based on its brand. So for that, if we are able to calculate this right hand side probabilities, we can make a statement about left hand side. It's wonderful, right? So now the wheel rotated and now the business we are running is 2019, Now we are running the business. Again, my friend called me, hey, you need to work on some analysis. Okay, come on, give me your ledger or give me your book, I look into it. He said, hey man, what exactly you're speaking? How can we store the data in a book now? Right? So we complete picture has been revolved. So we are not storing the data in a books, we are storing the data in databases. So what are the different databases we have? So we have MySQL database, we have SQL database, we have Oracle database, we have Hadoop, we have cloud-based storages, anything. So based on this, what exactly now people are storing the information in this databases. Now, in order to do this mathematics, I can't print it in a paper or I can't do all the calculations manually. So I want help of a tool. You can go with an Excel sheet, but you can't collect the data from MySQL or SQL into Excel sheet, right? You can collect the data from Hadoop. You can't put it down into an Excel sheet. It's difficult. So we want a third-party tool which can help us in order to do this sorts of analysis. For that reason, what we are using is the tool which can help us to collect the data, which can help us to prepare the data, which can help us to even clean and prepare gonna come into the same picture. We need to prepare and we need to clean the data, and even in order to build a model on top of the data. So I want a tool which can do all the four activities, which can collect the data, which can prepare the data with the help of cleaning, and which can model the data. So which is nothing but we call the tool as R programming. You can use R programming, or even you can use Python. Any of the tools can be utilized, right? But majority of the time R is very simple programming tool, so majority of the people and industries we get into R programming. So this is one of the major purpose of going with a tool, right? Why we are going with R programming or so. And in this entire process, I just want to walk you through the next stage. We are able to do certain sort of so why, in the sense, the major reason why a data scientist is taking up into a in industry is we get a problem statement. This is the flow chart of a data scientist. We get a problem statement. So based on this particular problem statement, we need to collect the data. So any problem need to be addressed by a data scientist only through data collection. After collecting the data, I need to understand the data. I need to understand the data. So based on my client requirement, I'm going with data understanding. After understanding the data, I'm just going with preparing my data. Again, data preparation, I need to do it based on my data understanding. After preparing the data, I want to choose any of the method. It may be like time series, or it can be from this. Either I can go with time series or I can go with machine learning and linear regression. So any of the technique I can choose it, or even from this I can pick one more way, which is nothing but deep learning and NLP. So this is what you are learning it. So this is your learning curve, or this going to be exact your real-time process. So you get a problem statement. Based on the problem statement, you collect the data. Based on the data you collected, you understand the data. Based on the understanding you do, you try to prepare the data, and then you try to go with something like your time series modeling. In case if the problem is related to, or data is related to time series, I go with time series modeling. In case no, it is not related to time series modeling, it is related to purely with respect to machine learning, or we need to do certain automations, we need to do some predictions using certain entropies or coefficients and all this, you can go with machine learning, or you would be going with linear regression or logistic regression. No, we are dealing with images, or we are dealing with text, we can go with NLP, or we can go even with deep learning, right? So this is the process what we are following when we are getting into any of the real-time life cycle of a data scientist contain these steps. So based on this, we are looking into various parameters. But before moving ahead, I just want to introduce you three major terminologies. So one is descriptive analytics. Let me walk you through that. I hope this part is clear. And based on this, let me go through the next stage, which is nothing but the difference between descriptive, predictive, and prescriptive, right? So when we are looking into descriptive, what exactly a descriptive gonna do is, this is the first stage of in order to do any analytics in a company with respect to data, a data scientist want to pick, or he want to start from descriptive analytics. So descriptive analytics is nothing but we call it as a post-mortem analysis, right? Why? In the sense, so whenever you get a problem about a company and they provided you with the data, you need to do post-mortem analysis on the data they provided. Means you need to understand end to end of the data, right? So the problem may be from sales, or the problem may be from marketing, or it may be from operations, or it may be from finance. So based on that, you just need to understand the exact amount of what data they provided, what are the columns they provided, how many rows they provided. You need to do all sorts of the initial data understanding. That is very important. And we call this complete understanding and collection of data as descriptive analytics. So what exactly you are doing is you are getting some good confidence with the data what they provided, right? So for that reason, we are looking into the post-mortem analysis with the help of by looking into sales, by looking into marketing. It may be any business vertical. So based on that, you collect the data and you do the initial post-mortem analysis. We call it as descriptive analytics. Once the descriptive analytics is done, based on the descriptive analytics, so we choose between whether we need to go with linear regression, or we need to go with time series, or we need to go with predictive analytics. So what exactly a predictive analytics gonna contain is, so we are making a statement about various questions on what is likely to happen. Means we are making a prediction. So a person came near me, hey, I want to say whether my loan going to be approved or not. So I want to use predictive analytics to make a statement, what are the likely to happen that he gonna get a loan, or what are the chances that he may not get a loan. For that, one of the very important technique is predictive analytics. So after going with predictive analytics, how we do a predictive analytics is, we can do some mathematical equations, we can use some rules, we can use some algorithms, right? But all these things we used to do manually in 1980s, when there is no computer, when there is no databases. Now we can do everything with the help of our programming, or we can do it with respect to Python. So this is the stage what we are able to work on. We can work on our programming, or we can work on Python. So when we are working on to this particular R programming, or when we are working on Python, so one of the major skill which is important for us is, so what is how do we benefit from this prediction? So when we are going with any of the predictions, we need to speak about how can we benefit it. So now a person is coming it, a salesperson or a quality person can say whether the loan can be approved or not. So you are saying you can do the same prediction with respect to a program, with a R program or something like that. So what is the benefit we are able to achieve is very important. So how will this decision impact everything else? For example, when you're running this particular process in a business, so how can this impact your entire process? A quality person is doing this process manually. Now you're replacing that with an algorithm. So how can this impact everything? How can it impact your stakeholders? How can it impact your business people? How can it impact your customers? Whether your customers going to be happy or not? Yes, it's going to be customer satisfaction. There is no fraud going to happen. So but based on the genuine details, we can say whether the loan can be approved or not. So even they can get a loan within 5 minutes, right? Lesser amount of waiting time. Yes, customers getting satisfied. What is the benefits of it? So we are able to increase our business nearly 30%. We are able to reduce our expenses nearly 40%. Wow. So we call all the statistics comes under prescriptive analytics. By doing a particular prediction, what is the impact of your prediction and how can it impact rest of the process is explained in prescriptive analytics. So predictive analytics is used in order to understand what is the likelihood or what are the chances to happen this event, right? Or in order to get this sales, or in order to get the similar kind of sales in next July. So all these things we are able to do it with predictions. So the predictions with respect to certain benefits and the impact can be done with the help of prescriptive analytics, right? So this is the core idea and this is the basic profile of a data scientist. A data scientist can work under descriptive analytics, he can work under predictive analytics, so in order to work on a cause to get certain amount of prescriptive analytics, right? So these are the three major divisions of a particular data scientist. Now, before getting into a data scientist, we can use any sort of tools. We can use any sort of tools like when we are dealing with data collection and everything, we can either use, I can use R programming or I can use Python. Any tool can be used. It's up to us, or I can use Weka, or I can use MATLAB, or I can use SAS, or I can use SPSS. Any tool can be used, but why R is popular in the market is it is an open source. Even Python is also popular, equal levels. Why? In the sense Python is also an open source. So from our next video, I think now you got a picture. So what exactly meant by a data, we learned about it, which is nothing but data is called as set of measurements on a set of recorded values. We call it as data. And a data scientist starts always his process with data, problem understanding, data collection, data understanding, and data cleaning or data preparation, and choosing a right model or a right technique in order to solve the problem, right? These are the stages of nothing but a data scientist. But before going into the stages, we need to know how to collect the data before looking into problem understanding and before looking into the model. So we need to answer certain set of questions like how to collect the data, how to know how to do the coding in programming, what are the different databases we have, what are the tables we have, how to format the tables, how to give the connections between tables and your R programming. So we need to learn all this before looking into getting or building some analytics. We need to master all these areas. I think from our next class, we start with introduction to our R programming, and there we learn about various data techniques, various data structures, and all this. From there, we master our R programming. So this is going to be our next class, going to be introduction and installation of our R programming, friends. Thank you so much. And to do some coding, so one of the very important thing we want to do is we want to install our R and R Studio in our systems. So for that reason, let me walk you through. You can go to your browser and first you need to type rcran. So you need to click on this. In your rcran you can see comprehensive R archive, so you are able to see that. So in that you need to install it. For I'm using Mac OS X, so you can use download R for Mac OS X, or you can use it for Windows. If you are a Linux user, you can click on Linux thing. So I'm a Mac user, I clicked on Mac, and you need to scroll down. So here you can see the pkg file, so which is nothing but it is the older one, like 3.3.3. If you want the latest version, you can click on 3.6.0. so it got downloaded. I'm just stopping it. Why? In the sense I already have R in my system. After downloading R, by going into comprehensive R archive, so you need to go to the next on the next tab. It's better to open R Studio. So in your R Studio, you can click on open source and enterprise ready professional software for data analytics. I think you have this particular R Studio. So I want to download R Studio. When you are downloading, you have multiple things in R Studio. You have R Studio, you have R Shiny, you have R Studio Server, so on and so forth. So I want to download R Studio. So for that reason, let me go and let me click on R Studio. and it would be asking you for different versions. So Art Studio Desktop, if you are going with an open source like only for you can go with this, it's for free. In case no, I want to use it for commercial purpose, I want to use it in my company, then you need to go with Art Studio Desktop, which is going to be 999 per year, right? And if you are going with Art Studio Server, again it's an open source, and it is for free. And if you are going with our Studio Server Pro, I think again it is a paid one. For 5 named users, it is nearly pretty costly, $4,975 per year. So I think we are doing it for our own sake, so it's better to go with open source. And here I need to download my installer. So for which thing I just want to download it, I want to go with Mac OS X, and I want to download this installer. So let me click on this. So if you click on it, even the Art Studio is getting downloaded. It is my Mac version. If you want, you can go with your Windows version or Ubuntu version. Ubuntu is majorly for Linux users, and Fedora, right? If anyone with Red Hat or so, they can go with this Fedora version, right? So these are this is how you need to download it. And once you download it, this particular tools, it's better you can, after installing it, first you need to install Arcran. After downloading it, you need to install Arcran, and after installing Arcran, you need to install RStudio. Then you can see this kind of logo, RStudio and Arcran. No need to open Arcran. It is like it's not an IDE. Our CRAN is purely the console. It may not be as good in user interface. So to have a better user interface, we are going with Art Studio. Let me click on this. So now it opened. Now when you have your Art Studio, it's gonna look the same way how exactly it is looking in my screen. So this is called as your global environment. If you create any variable, you are able to see that variable in the global environment. And this is your particular console. If you are able to plot any graphs, you are able to see it. If you want to install any packages, you can see this packages. And if you want to have any files, I think you can see the files. Help, if you want any help from R or Art Studio, you can check it here. This is your viewer. Majorly I want to put it down to plot. And this is your console, means you are nothing but your Arcran is nothing but your console. So whatever the scripts you write, you can write it down here, right? But if you want some free hands-on, for example, I want to create a data d equals to 1 comma 2 comma 3 comma 4 comma 5. I can run it. So your square braces and all these things may not be pulled out in your R programming. So I just want to correct it, man. I just want to correct it. You can't do that, right? You can't go to the above line. Again, you want to write it D equals to, so C of concatenation of something like this, and you want to enter it. You are able to create a value, right? So if you got any error, you can't correct them. So what our studio done is, no need to worry, I'm making everything at one place. You can just click on this and you can say R script. It is nothing but your notebook, right? Or a text pad. So the whatever the script you have, you can execute it here, the same D equal to, so C of, or I want to start with square braces as we done it in the before thing. So if you say enter, it doesn't work. So in console, to execute a command, you need to use enter. But when you're going with our studio, the about text editor, to execute this, you want to use control enter. If you are a Mac user, you need to use command return, right? So it is throwing me with an error. What is the error? I don't want square braces. I want to use parentheses. So let me create parentheses, and C is nothing but concatenation or join. So I want to add multiple values into this. So you can say control enter. You are able to see the command got executed. So when you are looking into any of the programming language, you are able to see three major terminologies. If you are using hash mark, it is nothing but a comment. So I'm using hash here. So you are able to see the first one is value. Second thing is variable. And third one is nothing but a function. And fourth one is nothing but your packages. So here packages are nothing but, in your phone, I think you would be installing the applications. So we call those applications as nothing but the packages, right? So always we need to store this particular value inside a variable. right? It is something like I want to hold them, I want to call them whenever I want, I can just address them for that reason. So I want to store this particular values inside a variable, right? So I want to do a task on this variable, then I want to go with a function. So function, I want to create d equal to list of. So here list is a function. Always remember the list going to be denoted with a blue color square rectangle shape. So I'm using a command list and I'm writing this data. Control enter, right? So list is used in order to work on a particular activity, or I want to do certain task on a variable, I would be going with a function. So here list is a function. I want to calculate a mean is a function. For example, I got d here, I want to create one more variable d equal to, so concatenation of 1 comma or 12 comma 3 comma 4 comma 5 comma 6 and control enter. I want to calculate mean of d, right? So if I say mean of d, I'm able to get the mean of the particular data whatever you created. So here mean of d is nothing but mean is a function. So what is the purpose of a function? To do certain activity on a variable, I use function, right? So what is meant by a package? There are tremendous millions, like millions of packages, or we can say thousands of packages are available with our programming. So what exactly we do in our phone is like I want to download an application, I go to my app store, or I want to download an application, I go to my Play Store and I select for that particular app and I download it. But when you're getting into your R programming, to download any of the application, you want to use a particular library, which is nothing but installed.packages. What is the package name I want to download? So I know I want to download a tree, right? You can say control enter, right? So when you're running it, it is saying that warning, it is installing, tree is not available. I think tree is not available. I think it is already present in my version. So I can say library of tree. So one particular line, I think I loaded it. It is already present, so it threw me with an warning. So install.packages is meant to install a package or a library or a software, let's imagine, right? So tree contains bunch of functions related to decision tree algorithm, right? So library is used, so when you downloaded a particular application, so just the download doesn't suffice, you want to open it every time. So whenever you downloaded it to use that application, you want to open it. So library is meant to invoke a library or a package, right, or a software. So to invoke means to open that. So to cross check it, you can do one thing. You can go to packages, you can search for tree, you can see the what is the description of this package. It is a classification and a regression trees. Majorly you learn it in machine learning. So I don't want to use it, I can just uncheck it, right? So when I done unchecking, what happened, detach is happened. Again, if I run this command, you can see there is a check mark, right? So in order to install a package directly, you can do it from here. In case if you are able to search it, you are able to find it, means the packages are installed already, no need to install it. If you install any new packages, you can search by name. These are all the package. There is package called A3, right? You can click on install from here, it would be installed, right? In this way you can see that it is installed. After installing it, so let me search it for A3. I got A3 accurate, adaptable and accessible error metric for predictive models. So I just want to say library of A3, right? And I can run it. So it loaded, you can see there is a check mark. In similar lines, I want to search for something related to NLP, right? There is a library on NLP. I just want to install it. I don't want to use this command, I just want to use it by command install.packages of, I want to use it in double quotations, NLP, control enter. right? You can see it got installed. Now let me check whether there is NLP or not. NLP, yes, I got natural language processing infrastructure. You learn it in our last library, in our last module. So library of NLP, and let me run this. Yes, it got invoked. So in order to use it, so installation, the install.packages is only one time you need to do it for entire your usage. But whenever you close your RStudio and when you open back again, so you need to invoke the libraries. If you want to use the commands of NLP, you can see NLP. If I click on this, these are all the various commands which are present in NLP. So I want to see various commands inside A3 dot. So these are all the various A3. These are all the various commands which are present in A3, right? So I want to see what are the commands present in your tree. So what I'm doing is tree. So I just want to, yeah, in order to go to the library, you want to use tree. So these are all the various commands which are present under the tree library. So a package contains a functions. Functions are used in order to do a certain activity on a variable, right? And a variable contains nothing but the numbers. So we can use our programming not only for this our basic mathematical purpose. So I want to use it for calculations. So when I'm going with the calculations, I just want to use one, control enter. So I'm able to see this. So we are able to do the multiplication. I just want something like 3 divided by something like, I want to divide 3 by 4 and let me run it. Yes, you can do the division operations. So you can use your particular R programming for mathematical stuff and whatever in order to import any particular data. For example, I want to do even data importing. So in order to do data importing, data, there are two ways to import the data. One way is I can click on this import data sets. I want to import it from my text database or from my Excel database or from SPSS or from SAS or STAT. I want to import from my need to install the particular libraries in order to import it. It is importing which are required to import a particular file. Yeah, perfect, it got imported. So now I just want to load my data, browse. I just want to open knn.csv. I have a CSV file. I just want to load it. Open, right? It is a CSV file, so can't establish the input is either XLS or XLSX. So you want to import only this format. So you can do one thing, there is no problem. Either you can convert it or even let's try from text. Does it happen? Right, this is how your data gonna look like. Import it. So if you're unable to import it with Excel, the only way the CSV is taken as a text format, you are able to import your KNN dataset. You're able to see all the data is present over here, right? So either you can do it directly from here, or you can do it one more line. I want to import my data as a cancer dataset, and I can use equal to, so read.csv file.choose, right, and say control enter. You're gonna get a pop-up, and in this pop-up you can search majorly. So knn.csv, you can go to downloads, you can select it and you can open it. Now you have the data imported with the name cancer, right? So these are the two ways to import the data. Either you can deal with your directly with a command, or you can deal with your particular library directly. You can import it from the environment. So these are the ways you have it. So once you're done, Now I want to do some basic understanding on this particular data. So if we want to go to any of the data set, for example, I want to see cancer, right? So in order to go to the columns, you want to use a command dollar, right? So I want to see diagnosis, I want to run it. So it contains benign and malignant, right? So the purpose of dollar here is majorly meant to work on column specific operations you would be going with in this format. So in similar lines, you can do one more operation. So I just want to calculate the mean of the data set. I want to calculate mean of the particular column. So what you can do, you can go to you can say mean of cancer data set. If you say directly, if you pass cancer, it's gonna throw you with an error. So why? In the sense argument is not numeric or logical. Why? In the sense inside your cancer data set you have diagnosis, which is a alphabetical data, so it throw you with an error. So no, I want to calculate it for a specific column like radius mean, right? You are able to calculate the means in this format, right? So we look into the more hands-on on our particular this R programming on our next e-learning. So I hope you got some basic picture on how to install the packages, how to install your entire R and R Studio, and how to use this. For example, I want to, before closing it, I want to clean the console. You can use Control L, right, so that it is cleansed. So now you can see this variables got executed. If I run it, it executed, but I don't want this. If you clean this, we call it as a broomstick icon. If you clean it, entire global environment is empty, and if you run the same command, it's gonna throw you with an error, cancer not defined. Why? There is no variable here, so I'm saying cancer not found, right? So on the next class, we look into some of the basic commands on our programming, and if time permits, we look into some of the visualizations with our programming on our next e-learning session. So try to install your R programming while you're getting to the next video. This is the prerequisite, and we would be whatever the things are required to install on the next classes based on the topic. I would be making you to install it. So thank you so much. So catch you on our next e-learning session. Thank you. On installation part of our R Studio and even our CRAN. I hope that everyone are pretty installed with our Studio and you are having in your systems, you are completely good and up running with our Studio. Now this is our time to start with some basics in order to get started with. So let me introduce to our R Studio. So I got this. I would be sharing this file. It would be available in your resources. So what I'm doing is, on last class we just said we are using equal to. So in R or R Studio, you can use either equal to, or you can use less than hyphen. So even a less than hyphen acts like your same as like your equal to symbol. But why we are going with less than hyphen is it supports some majority of so what exactly I'm doing is I want to create 1 to 100, so range of 1 to 100 values in JDev. I want to store it in JDev. Let me run it. So I can see the values are ranging between 1 to 100 under JDev. In similar lines, I want to create the values which are ranging between 2 to 50 under Sweta, so which is integer. And I want to store the data which is ranging between 3 to 10 under Gopi. I want to create a data called as Bhargav from 4 to 5. And in similar lines, I want to create Prasad, which is ranging from 5 to 10. So which is also in your I store it in Prasad, and in similar direction from 6th integer to 11th integer, I want to create the range from 6 to 11. I created it like 6, 7, 8, 9, 10, and 11, right? So I want to see I just want to see what are the various variables we created. So in order to see the number of variables which are having in our global environment, so we can use the command ls. So ls is nothing but it gonna print us with list of variables, or list of variables which are provided in our global environment, list of variables which are provided or present in our global environment. So in similar direction, I don't want out of all these variables like Bhargav, Gopi, Jayadev, Prashad, Sharath and Sweta, I want to remove some of the variables like Gopi, Prasad, Jayadev and Sharath. So I'm using here, so removing variables, I would be using a command, this particular thing, which is nothing but rm is used in order to remove it. Let me run it. You can see Gopi, Prasad, Jaydev and Sharath got deleted. They are not present, they got deleted. So till now whatever we created are nothing but we provided with range of like 1 to 100 range, or 2 to 50 range, or 3 to 10 range, or 4 to 5 range, or 5 to 10 range, in this way. But if I want to create my own specific numbers, right, what I need to do, you need to go with C, is nothing but we call it as concatenation. Concatenation. So by using this concatenation, or by using this combine, so we are able to go with different levels of data like 1 comma 5 comma 6 comma 8. There are different proportions, so we can add it and we can store it in one variable called as Jayadev. Let me run it. Yes, so we are able to store this particular data Jayadev, which contains 1 5 6 8. I'm able to store it successfully with the help of concatenation, or with the help of your combine parameter. Right, so in similar lines, in similar format, I'm creating one more Sharath, so which is a value contains 10 20 30 40 50. I created it, so I want to remove Sharath. Yes, I can remove it. So if you want to create Sharath again, you can create it. Now I already created Jayadev, which is 1 5 6 8. In similar lines, I want to create only 4 parameters. So with Sharath, again, I'm creating it. So I don't want to remove it now. Right. So what I'm doing here, I want to create Prasad. So which is a multiplication of Jayadev and Sharath. So which is nothing but I'm doing multiplication. I'm doing multiplication. So let me run it. Yeah, I created Prasad, which is a multiple of Sharath into Jayadev. You can see it. If you want to see, you can run the command by saying print of Prasad. Right, you are able to say print of Prasad, so you're able to see that we multiplied each and every value. In similar direction, I want to create a new thing, which is nothing but Swati, so which is a subtraction from Jayadev. So let me run it and let me see what is. You can run it with print or without print. So I'm using print command, so that that would be more specific. If I run it, yes, I subtracted Sharath from Jayadev. And in similar direction, I want to divide Sharath with Jayadev so that I can store the data into Satvik. Let me run it and let me see the data. Yes, it got divided. So I don't want to divide it in this format, Sharath by Jayadev, but I want to divide Sharath with certain number, right? So you can do it, so that let me see what is present inside Sharath 2. You can see this. I got printed with 5, 10, 15 and 20. Right, so if you want, you can remove it. We already looked into this operation. Right, I'm just cleaning it. Now I want to see the list of variables. So we created from line 1 to line 46, we created number of variables. So I need to see what are the what are the various variables which are present. So I'm using ls command. So there are nearly 1 2 3 4 5 6 7 8. So you can ask me what exactly this number 6 and number 1. So we are saying that Bhargav is having a position of 1 and Sharath is having a position of 6. So now in order to know what is the level of Sharath, again we want to start from here. Rather than doing it, they would be providing you with the first variable index position. So they are at 1 and Sharath is at 6th index. So Swati going to be 7 and Sweta going to be 8. So in the similar direction, I think whatever we done from line number 2 to line number 46, just we are creating some basic values, and we are trying to do some mathematical operations like some sort of basic mathematics. We done it. So now what we are trying to do is I want to do certain sort of operations by using concatenation. Again, I want to create a variable called as temperature. So with the respective concatenation, which is nothing but temperature 1, I just want to remove this and I just want to run this. I create a temperature 1, and I just want to say calculate mean of. So why we need to create a variable? Again, this is a question. So why we need to create variable? So we already looked into last class, like variables are nothing but we store the set of values inside a variable. So now I want to calculate a mean of this all these values 1 2 3 4 5, and if I run it, it's gonna give me only one value. So we can never calculate the mean. So I got a doubt, let me use square braces inside it, and does it happen? I'm not sure, I'm just checking it. So error. So it doesn't accept any square braces. So only method we left with is, so I can create a variable called temperature, and instead of passing 1 2 3 4, I can pass the variable temperature 1, and if I run it, you are able to see 39. So in any function we can pass only the variables, and when you see the variables are with a color pink color, you can see what is on the last class we discussed, the functions are with a color blue and your variables are with a color pink color. So if you are able to see a pink color, it is nothing but a variable. So now I calculated a mean for temperature 1 variable. So when you are going with any of this calculations, try to remember that. So it's pretty important to create a variable in order to apply any sort of functions. So in similar direction, so I'm creating a variable called as x, I'm creating a variable called as y, and I'm calculating a variable of something like mean of x. So there is one more type, this is called as normal concatenation, or you can store the data in a list format. So list is like we can store any format into list. You can store integer, you can store float, you can store your string value. So anything which is with alphabetical, we call it as string, and any data which contain with numbers, we call it as integer, and any data with decimals, we call it as float. Right? So I want to create it. I created a list which contains 11 elements. Right? So these are all the 11 elements which are present in your list. Right? So let me go back to my list called as rain. So it contains how many overall? You can see list is like a data and your concatenation is like a normal values. So in order to create a kind of data, this is a kind of data structure. So list is one way to store the data. We call it as list data structure, and the property of a list is it is mutable. What is meant by mutable property? So if you are able to replace any value inside a list, I call it as mutable property. So how I need to navigate it? So I want to go and I want to print 1. So what exactly I printed? So this we call it as index values. Let me write it down. I want to call it as indexing. So I want to print this particular y. So let me run it. Yes, I'm able to create it. So if I say 2, let me run it. I'm able to go to the second index. I want to print 3. So what is the index value? 1 2 3 4 5 6 7 8. So in order to print 3, I want to pass an index of 3. Right? Sorry, 8. So when you are doing it, you are able to get the index of this particular element, which is nothing but 3. The index is 8. So to make it even more simple, if I'm creating a list of data with values A, B, C, D, E, and F. So each and every value your R programming don't remember it with A, or it doesn't remember it with B, or it doesn't remember it with C. So how exactly it remembers it? It starts to remember with 1. It gives an index like 1, 2, 3, 4, 5, 6. So overall, how many elements you have? 6 elements. So A going to be 1, B going to be 2, C going to be 3, D going to be 4, E going to be 5, and F going to be 6. So in similar direction, now I'm able to see here there are index values, there are list of values, and I'm able to navigate them with respect to the particular index. So now at this particular index, I want to replace it with 80. Let me run it, right? And let me run rain1, and what are the value present inside it? So if you're able to see, index 8 got replaced with what? With 18, right? So now we call this property as mutable. So if there is any data, so we can replace it after creating it. We call it as mutable property, right? So if you are able to go for joining the multiple combinations of list is nothing but we call it as a matrix. So to create a matrix, let me show you a small example. I want to create rain, whether there is a rain or not. Overall, how many values you have for in order to create a rain. Let me write it in separate line. So rain, I want to say whether the rain is present or not, yes or no. So S, yes, no, no, and yes. So I created a list called as rain, as well as I want to create a new variable called as temperature. Based on this temperature, we need to say whether there is a rain or not. So we need to use single quotations when we are using a string. Without that, it's going to throw you with an error. Let me run rain. I created it. And let me create this particular temperature. I created even a temperature. So based on that, based on this to list, I want to create a particular matrix. So I want to create a matrix. So a matrix, I want to create a matrix based on concatenation between rain and between temperature. So matrix of C concatenation based on rain and temperature, I want to create a matrix, but how many columns you want? I want only 2 columns. Let me run it. Yeah, I created a matrix which is with a 2 columns and which is formed based on 2 lists. So when you are looking into your data, before looking into this, you need to understand some basic terminology or a basic math related to data, right? So the first point is always we store a data in a format of scalar. What is meant by a scalar? So anything which contain only values like 20, or it may be a name, or it is something like decimals, we call it as a scalar quantity. There is no direction, only there is magnitude. We call it as scalar. So the same scalar, if I am able to stretch it towards one direction, right, I can call it as a list, right? So we can store n number of values inside it, like 1 comma 2 comma 3 comma 4, right? And each and every value is having a certain amount of index value, means there is a magnitude and there is a direction. So we call it as a vector, right? So any variable which contains both a direction and a magnitude, we call it as vector. So in similar lines, so the same line, if we are able to stretch it towards 4 dimensions, all the 4 sides, we call it as a plane, or we call it as a matrix, or there is one more name, we call it as array. Any name is same, right? You're calling it as a matrix. So in a matrix, so it is a combination of a list, is nothing but we call it as matrix. So that's what we created over here, right? So, and if the same matrix, if we are able to expand it to backside, which is nothing but the depth side, so we call it as a 3-dimensional matrix, or we call it as a cube, or we call it as a tensor. These are the names. In similar direction, so now let me clean it and let me go back. to my particular line 74. So I created a matrix, but I haven't stored it anywhere. So I want to store it with climate data, and let me run it. So now you can see I created a matrix called as climate, right? So which is a list of 10. So let me open it and see it's a matrix format, right? In similar format, what I am doing is I want to create a particular list. So I just want to join the rain and temperature as a list format. So I can see it is joined as a list with two list elements. One is temperature and another one is rain. And even if you're able to understand, so when I'm using two lists, it is not in a matrix format. If I open climate, this is not a data. So I want it in a data representation. So what I need to do is I can't use list format over there. I need to use concat. So when I'm using concat, so it's going to be creating me a proper matrix. So let me run temperature and let me run precipitation. So let me create a matrix using temperature and a precipitation, and let me store this inside something like weather, and let me run this. So I created weather. So you can see the weather is in a format of data. So now we created a data. So we looked on to the definition on our very first e-learning called as set of measurements on set of recorded values. So in this way, you can create a data. So from very scratch, so by using the manual commands, by using our programming, we created the particular metrics. You can ask me, on yesterday, on the very first e-learning class, you said a matrix, sorry, what is the definition of a data is set of measurements on a set of recorded values. You are calling it as data. But when I open this weather, it doesn't look like a data. Why? In the sense, it is in a structured format like row and column wise. But what is this column name? I don't know. So if you don't mind, can you help me out with the column names? So we want to name these columns. For that, we can use one more type of data to store it, which is nothing but we call it as data frame. So I'm creating a data frame where I'm calling Prasad1 is the column. Under this, I'm adding this list of values, which going to be the rows, and Gopi1, under this I'm adding this list of values, which is nothing but rows, and under Sharath1 we are adding this list of values, which is nothing but rows. So I want to run this piece of command. Let me run it. I created a data frame. So let me see how exactly it going to look like. MB1, let me run it. Yes, we are able to see set of measurements on set of recorded values. Yes, we created a data. Now let me open this MB1. Absolutely. Now this is in a proper format. Now you can click on it, or to view any data in our programming, you need to use a command view via EW of MB1. And remember everyone, so your R is a case sensitive. So now in place of V, if I use small v, and if I run the same command, it is throwing me with an error, could not find function VIEW view, right? You said everything, whatever you said, we typed it VIEW, but it is throwing me with an error. The problem is case sensitive. You need to replace it with capital V, right? So perfect, well and good. Now I just want to navigate it. I want to do certain multiplication. You can see column wise multiplication. What I'm doing column wise multiplication. Let me clean it and let me create it. I want to create A is equal to, so I want to go to MB1. So dollar Prasad, which is a numeric data, so which is multiplied with MB1 dollar Gopi, which is also a numerical data. Let me run it, and I stored it in A, and I want to see what is the value of A. So print of A small. Again, if you type capital A, it's going to be the case sensitive. So use small a, run it. Yes. I got it. So in case, right, in this way we are able to do it for our particular things. I hope everyone are able to understand. So in similar lines, what I'm doing is, so whatever I have, that's well and good. Let me try one more thing. If I want to store, or if I want to create a new variable, right, in the existing MB1, I just want to try it. MB1 dollar, something like, I want to call it like some other name, ABC, right? I want to use this calculation and I want to run it. So what happened? I just want to see my data frame, view data frame. So sorry, not view data frame, it is view MB1, and let me run it. So now you can see I created a new column. So by doing the column wise multiplication, you can store it and you can create a new column in your existing data frame. So this is one of the major benefit we are able to see for data preparation. Now I want to, by using sales and profit, I want to create an expenses column in Excel sheet, right? So no need to do anything, just import it. Hardly it takes you 1 minute. Just you'd be going to that column, you use your mathematical operations and you get it done. So this is one of the major reason why companies are nowadays navigating towards our programming, right? So we done it in a similar format. I want to create a user defined function. All the time we can't use the functions which are available. Some cases even we want to do some subtractions, we want to do some multiplications. So all the time your R programming may not be doing it for your company related task or mathematical operations as well. So here comes a solution which is nothing but we call them as user defined functions. So by using this user defined functions, what I'm trying to do is I want to create a function called as cube. So what is the logic inside it? It need to multiply any value with 3 times. So it is nothing but we are creating a cube. Let me run it and I want to test it. If I say cube of 2, what is the value? Wow, 2 into 2 into 2, it is 4. I just want to apply this on my MB data set. So what exactly present in MB? There is 38, 32, 34, 38 and 40. So now MB, I want to say cube of MB1 dollar Prasad. Let me run it. You can see all the values in Prasad got multiplied for 3 times, power 3, right? So that I'm able to cube it. And even, for example, after cubing it, you want to store it in a new data set in your same existing MB1 dollar cube of Prasad. And I want to run it. Let me see whether this is added or not. View MB1 and let me run it. Yeah, even a cube of Prasad got added up. So whatever the mathematical operations you are doing, you can do it. Or if you want, you can create your own user defined function and you can add it to your current existing variable. So this is how we would be playing around with some of the basic operations and basic data creation we done till now. So we call it as data creation. So in a similar sequence, now we are looking into some of the inbuilt commands and some of the inbuilt functions, which is nothing but we call it as I want to create a sequence which is ranging from 1 0 to minus 0 1. Let me run it. You can see I started from sequence of 1 to 0, means I want to stop it. So how exactly I want to create a sequence with a difference of 0 0.1. That's how we created it. So with a difference or with a exact interval of 0 0.1 difference, we created a sequence from 1 to 0, and I stored this data into A, right? So if you want to set your working directory, You can set it like this, right? But not required. Your working directory is no need to set it up now. Why? In the sense, already you are majorly we use working directory setup to import a data. Now I don't want to import the data in this format, which is time consuming and some more error format. So I want to use this simple command file.choose. So I can choose it from any of my environment. Let me run it. I got it. I want to load fraud data.csv. Let me check it. Yep, I got my fraud data.csv. Let me open it. Right, you can see fraud data is imported, which contains 11 objects and 9 variables, means 11 rows and 9 columns. Let me open it and see. Yes, it contains 11 rows and 9 columns. Wonderful. Now I can see there is a column called as credit line. I just want to do some ascending order to this credit line. So let me run this piece of script, line number 128, right? So let me see whether it got ordered or not. So let me open this new column called as ordered. Yes, right, it got ordered. So now based on this, I want to create my fraud data. Let me run it. Yes, you can see my credit line got ordered. If you want, you can store it into fraud data, a new variable, fraud underscore data, to see it in your global environment. Yeah, I got fraud underscore data. And if I'm looking into credit line, yes, it is in ascending order. So you can do this kind of operations. And I don't want ascending order. I just want to create descending order. Again, I'm creating fraud underscore DSC. So you can look into the command. What exactly we are doing is, so you want to order this fraud data dot credit line across comma in the sense row wise. So after doing order, you need to reverse it, means you are doing a descending order. And you want to pick whatever, when you are doing descending order also, only the index positions are picked. If you observe it, based on the order, the index positions are picked up. So in the similar line, based on this index positions, so try to get me the data from fraud data and store it in fraud underscore disk. So when I'm running this, when I'm going to fraud underscore disk, I'm able to see the entire data is in a descending order, right? So this is how you can create it, the order-wise operations. And now what I'm doing is I just want to work on some joins, data joining, right? So for that reason, I just want to use two different files. One is plasma.csv and another one is diabetes.csv. I want to use a command file.choose and I want to run it. And let me search for in my system plasma.csv. Right, it is not there. I think so. Let me go to another folder and let me search for it. So when you're having this access, I think that would be great. You can search entire your system and you can see where exactly you are able to find the file and you can work on it, right? That's one of the best opportunity. I want to go to my data science in machine learning, data modeling files. So I want to look for plasma.csv. It is available. I loaded my plasma.csv. This is the data what I have: number of times pregnant, plasma glucose concentration, diastolic, blood pressure, triceps, skin fold thickness. I imported the data which contains 14 rows and 4 columns. In similar direction, I just want to import diabetes dataset. Let me run it. And again, let me go back and let me choose diabetes.csv. I got my diabetes.csv as well. It imported So yes, it contains 14 columns and 14 rows and 3 columns: serum insulin, body mass index, diabetes pedigree, function, so on and so forth. Right now, what I want to do is, in order to join two columns, so we can use to join two columns, or we can say to join two data sets, we use cbind. In the sense column bind, right? Let me run it, and I want to store it in CC, right? So let me go to CC. Yes. So 4 rows we have, and we join the columns. Now the 3 rows from plasma dataset, the 4 rows from plasma dataset, and 3 rows from diabetes, overall it is giving us a result of 7 columns, right? And 14 rows. So your data need to contain equal amount of rows, and you can have it unique, different levels of columns. Column count is not a problem, but number of rows are pretty important, right? So in the same direction, I want to use one more command called as merge. So let me work on the merge command. So for that, I want to import a data set called as all transactions. So for that reason, I'm choosing file.choose. Let me choose all transactions data. I have this all transactions data. So what is the size of it? It is like 9 objects, 9 rows, and 10 columns. I just want to import credit data file dot choose, and let me go for my credit data. Credit data I have. Let me import it. So the credit data contains 5 rows and 4 columns. So what I need to do? So here we use the cbind when you have equal rows and different columns. All right, we are using merge in order to join these two different all transactions and a credit data. Let me run it. So let me go to ctwood. So it is able to pick only 5 rows. Why? In the sense the least amount of rows are present in credit data, just to overcome the null values. So it merged only the 5 rows, and the rows and columns got merged. If you say that no, I want all the things need to be merged, if you run it, if you go to ctwood, yes, it created all the 9 rows. You can see some positions are null values, right? So this is the problem we are able to see. Merge can be used to join between the rows and columns, irrespective sizes. If you have it, you can go with. So rows and a particular rows and column wise, irregular column and row wise joining, you can go with merge command, right? I want to calculate now. I hope it is clear up to this. You can work, you can see, you can have a look over it. So what exactly we are doing, we are importing the data, we ordered it here, and based on the index positions, we made, or we filtered the data and we stored it in fraud data. And in the line 131, we worked on the same kind of operation, which is nothing but we are doing descending operation. So on the line 136, we imported plasma data, and in line 37, we imported diabetes data. And we need to join both plasma dataset and a diabetes dataset. For that, we are using a column bind command. When there are different columns and equal rows, you can use cbind, right? And in similar direction, as you have a cbind, you have rbind, which is like row bind, row joining. So if you are having same data set, right, same columns, but you want to add more rows, you can use rbind, which is majorly meant for row wise joining, right? In the same thing, what we are doing is, if there are, if we, when different row and columns, then we use merge command. So by using merge command, we are trying to join this particular irregular shape of rows and columns into one by using merge command, right? In case if you say merge all equal to true, it is not going with least amount of row count, it is going with highest row count and it is joining it, even though it creates the null values. So when there are null values, we can't calculate the particular, for example, let me go to ctword and let me go to fake id. It contains null values. I want to calculate the mean of it or sum of it. If I run it, it is throwing me with na. I can't calculate the mean. Why? In the sense it contains null values. Null values doesn't mean zero. We call them as empty cells. So in order to calculate the sum for a particular column called fake id, I am saying wherever there is null value, try to remove it. I'm saying it as true. If you run it, you are able to calculate the sum of it. By removing na.rm, you are able to do this particular operation, right? So this is how we would be working on. So we looked in before looking into, I think, this is how we would be working on data preparation, data creation. We looked into data creation. We looked into data preparation and data creation using data frame, and we imported the data, and then we worked on data joining as well. So these are the various things what you learned on this today class. Even you worked on metrics, you looked into creation of list, you looked into creation of normal data using concat. We looked into doing some mathematical operations. After doing mathematical operations, storing it into a specific variable, we looked into it, or adding it to our current data, we looked into it. So this is the overall process what we looked on. So these are some of the basic commands of our programming. On our next e-learning, we look into visualization, we look into cleaning and all this kind of areas, right? So thank you so much. You can find this data in your particular resources tab. Thank you so much. So by viewing it, I'm able to see there are 32 rows and 11 columns. So it contains miles per gallon, it contains cylinder, displacement, horsepower, DRAT, etc. and etc, right? So now I just want to check. So let it be like data understanding. I imported the data using some view command from my inbuilt R studio, and I just want to understand the data like what is the mean, what is the median in this format. So I'm using summary of empty cars. If I say summary of empty cars, it's gonna provide me with complete description about what is the minimum value, what is the first quartile, what is the median value, what is the mean value, what is the third quartile, what is the maximum value. So we are able to understand the complete distribution of a data by using summary command. So summary is used in order to describe the specific data set. So in order to describe that specific data set, we use summary. And finum is nothing but it's a, you can see like empty cars, $miles per gallon. I want to do finum. So when I type finum, it's gonna provide me with minimum value, first quartile, it's gonna provide me with median value, third quartile, and even the maximum value. You can see the cross check. So minimum value, first quartile, median value, third quartile, and maximum value. So if you want, you don't want to see the particular what exactly we can say mean, and you want only minimum, first quartile, median, third quartile, maximum, it's better to use finum. And we have head command. For example, in order to see the first 6 rows, we can use head command so that it's going to print us with the first 6 rows. I want to see the bottom 6 rows, I can use the tail command, right? So head and tail are used in order to see the first 6 rows and the last 6 rows, right? So I want to plot a graph between two data points. One is cylinder and another one is miles per gallon. So I use a command plot of cylinder comma miles per gallon. So cylinder, if you are running like this, you can't, it doesn't execute. Why? In the sun, cylinder not found. So that in this case, what we need to do is empty cars dollar cylinder, and empty cars dollar miles per gallon. And if we run it, yes, we are able to see the plot here, right? So we are plotting between cylinder and miles per gallon. In similar lines, I want to plot between empty cars. I want to know the relationship between miles per gallon, and I want to know the relationship between horsepower. Let me run it so I can see. I call this kind of plot as scatter plot. We call it as scatter plot. So scatter plot is majorly used to identify the relationship between two columns, right? I'm looking into the relationship between two columns, which is nothing but miles per gallon, and another one is horsepower. So what exactly the relationship between miles per gallon and horsepower are? As your miles per gallon is increasing, your horsepower is decreasing proportionately. So there is a inverse proportionality, right? So this is what we can identify through our scatter plot is majorly used to identify the relationship between two columns. So in the similar uh, direction, we can check even the box plot is used in order to understand the distribution. I'm using empty cars dollar miles per gallon. If I run it, so I got empty cars dollar box plot. I got a box plot. So the here inside this box plot, this particular thing, we call it as lower whisker, so explains about minimum value, the minimum value of this particular miles per gallon, and this gives us about first quartile, and this is nothing but your median value, and this is your third quartile, and this is your maximum value, right? So in order to understand how the distribution is majority, you can see it is more towards minimum side. If you are able to see, there is a more distance when compared to minimum side. So majority of the data is more towards minimum side than on maximum side. So we call this property from statistics as skewness. So majority of the data is on minimum side when compared to maximum side. We call this property as skewness. By looking into this box plot, we can say whether the data is skewed or not, right? So what exactly I'm doing is I want to calculate the, even you can see here, I want to calculate summarize, means what is the purpose of summarize is, let me run it and let me print AB. What exactly it gonna do is I want to calculate mean of miles per gallon based on cylinder. So wherever there are 4-cylinder rows, those 4-cylinder engine means are calculated. So wherever there is a 6-cylinder, those 6-cylinder means are calculated. Wherever there is a 8-cylinder, those 8-cylinder means are calculated. So what is the purpose of a summarize is, so we're gonna calculate the mean based on certain grouping. So I want to calculate the mean of miles per gallon based on cylinder, right? For that reason, I would be using a command called as summarize. So in the same direction, I just want to calculate the mean of miles per gallon based on gear, right? Let me run it and let me see the output. For 3 gear, this is the miles per gallon, and for 4 gear, this is the miles per gallon, and for 5 gear, this is the miles per gallon. So either you can use mean or you can use even summary. I want to calculate summary of miles per gallon based on cylinder. Let me run it. Let me see the value. Yes. So based on 4-cylinder engine, the miles per gallon mean is this much. First quartile values are ranging in this direction. Medians, means, and third quartile and maximum, right? So the same like yours summarized, there is one more command. We call it as aggregate. Just the difference is the syntax difference we are able to see. No need to write the entire column, but rather than writing it, you are saying I want to calculate the mean of miles per gallon based on cylinder. These two things are present from the data empty cars. So if I run it, it is same as like your summarize output. There is no difference, but only the thing is the syntax difference we can see, right? right? So again here at aggregate, I want to calculate standard deviation of WT with respect to gear. These two things are present from the data set empty cars, right? So if you run this, again you got it. So gear, based on the specific gear, you got WT standard deviation values. Now I want to know the correlationship between the data set. What exactly meant by correlationship? So the relationship between one over the another parameter, we call it as correlation. So let me give you a small illustration. I think we done it in our very schooling. So whenever we used to get a graph paper and we used to plot x-axis and a y-axis, and when x is 10, y is also 10. When x is 20, y is also 20. When x is 30, y is also 30. When x is 40, y is also 40. When x is 50, y is also 50. So when we are drawing this connecting to all the points, so we can say this is a future line. Why? So there is a very good relationship, this particular x and this particular y. So when there is a relationship, it's pretty helpful for us in order to make a statement about x or y using one parameter. So there is a good correlation. There is for 50, y is also 50. If I ask, so for 60, what is your y? So if you just draw a line and if you connect it, we call it as intercept point, and you call this as y dash, and you say for x is 60 and y is also 60. We call this is nothing but called as predictions. So to make a prediction, correlationship is pretty important. If there is no correlation, we can't make a set of prediction. Let's take an example. Now if I say that I want to buy a Harley Davidson, in order to buy a Harley Davidson, we know that the horsepower is pretty high. When horsepower is very high, we can't expect a mileage. So how can we make a prediction without asking the particular seller, hey man, what is the mileage? No need to ask it. We know that the mileage going to be very less. So we know the relationship between horsepower and mileage. So as horsepower is increasing, the miles per gallon decreases proportionately, right? So with the help of correlation, we can make a prediction. So when we are getting, as years are increasing, so we know that the salary going to increase, so we call it as correlationship. So when your experience is increasing or your command on a particular subject is increasing, so the people who are knocking you increases. Why? In the sense there is a correlationship, right? So as you are using more with your phone, the battery going to drain faster, so we call it as correlationship. So correlation is very important in order to make any sort of prediction, right? So in order to check the correlation between each and every parameter, we can use a command which is nothing but cor, right? So let us look into it. So I want to write, so I want to check correlationship, and we call it as correlation coefficient, right? So when we denote it with small r. So we learn about this correlation coefficients and its importance. I think in our e-learning class on linear regression, there you would be learning more about correlation coefficient. Let me run it. So I got the correlation coefficients with respect to every column. The relationship between miles per gallon and miles per gallon is 100%. The relationship between miles per gallon and cylinder is minus 0.85, which is nothing but inverse proportionality. The relationship between miles per gallon and displacement is minus 0.84, inverse proportionality. The relationship between miles per gallon and horsepower is also negative, inverse proportionality. Means as one increases, another one decreases. If the displacement of an engine is more, your horsepower reduces. If horsepower is more, sorry, your miles per gallon reduces. If horsepower is also more, your miles per gallon reduces. So if cylinders are more in your vehicle, I think even it causes reduction in a miles per gallon. So there is one more column called as DRAT. So it is having some positive relationship, right? So what are these values like 0.84 or 0.77 or 0.68 or 0.85 or nothing but, out of, if there is 100% of data, out of 100% of data, 85% is correlated, just 15% is not correlated. So to measure this correlation, we look into core is the function. So no, we are unable to understand with this kind of metrics. We want to get some visualization. Then we have an answer, which is nothing but choreogram, which is nothing but correlation diagram. We call it as choreogram. So let me load this choreogram, and for that we want iterators. I'm loading it. So after doing it, I just want to plot choreogram of empty cars. So when you plotted choreogram of empty cars, you can see it in this format. So red color going to be negative correlation, and the blue color going to be the positive relationship, and the light color is going to be the lesser correlation. If the color thickness is very dark, it says that there is very strong positive. If the red color is very dark, it says that very strong negative. If the same values are light in color, if the shade is light, we call it as very less amount of correlationship. Right, so choreogram is one of the best visualization in order to understand the relationship between your entire data set, entire columns which are containing. So we can calculate correlation only between numerical columns. We can't calculate it for alphabetical, or we can't majorly like alphabetical data, we can't calculate it. We can calculate only for numeric and float. Right, so in the same direction, we have one more pattern, which is nothing but a histogram. So histogram is one of the very good visualization technique in order to understand. Histograms are used to understand distribution of data. Right, I want to understand the distribution of data, I go with histogram. So what exactly histogram is speaking about is we can plot histogram only for one numeric column or one float column, not to alphabetical data again. So if you are looking into this histogram, so the values between miles per gallon 10 to 15 are ranged minimum nearly 6 times. So in the data you provided from 15 to 20, they appeared like 12 times. So the data from 20 to 25, they just came into the picture nearly 8 times. Right, and 25 to 30, we can see it like 2 times, and from 30 to 35, so we can see 4 times. So the highest miles per gallon in your entire data set they provided is only 35 miles per gallon, and the least is 10 miles per gallon. For example, you want to build a model which can predict the miles per gallon up to 60. So does this data sufficient? Not exactly. Why? In the sense this data contains the format or ranges from 10 to 35. So this doesn't make any sense to collect the data. So if you want to make a predictions about 60 miles per gallon or 70 miles per gallon, you can't do that. Why? In the sense the minimum data ranges are 10 and maximum is 35. Right, so with the help of histogram we can understand why these people, how much amount of data they provided, so how much amount of columns, how many times each value is repeating, and even the repetition, which is nothing but the y-axis in a histogram is nothing but your frequency. So based on the frequency, there is one very important thing with frequency. Now we are spending more time on Python, or we are spending more time on statistics, or we are spending more time on our programming. So the more we spend time on, you would be more in our programming, you would be great in our programming, you would be good at statistics. But if you are spending less amount of time on our programming or anything, you would be having less amount of confidence. So frequency always builds confidence. So in your predictions, if your system need to build the confidence, we want more data. Means your system can give best predictions about frequency of a mileage around 15 to 20 kilometers per liter or miles per gallon. Right, so histograms are very important and very useful in order to understand the distribution of a particular data. Right, so as well as like our histogram, we can use box plot. I want to understand the particular distribution of miles per gallon. Let me run it. So I don't want this plot to be in vertical side. I want it in horizontal equal to t. If you say horizontal equal to t, so you are converting this particular histogram into, sorry, box plot into a particular vertical direction. So you can see the median is exactly it. 15 to 20 in between. Even if you see the above histogram, it is majority of the data is around 15 to 20. So the replicate of a histogram is nothing but a box plot. But one major benefit with a box plot is it can plot the outliers out of the box. If there is any extreme values, we plot them out of the box. So we call them as outliers. So what is meant by an outlier? For this, let me create one small data and let me explain you. Now, I want to create a new data called as D, and I'm going with concatenation. All the data I'm ranging between, right? These are the ranges. And unfortunately, there is 137, only 137 value. Let me run it. I created a data and I want to go with histogram of D. Let me run it. Right, I plotted a histogram. You can see there is a outlier at this point and majority of the data is in between this. I want to plot a histogram box plot for D. So you can see there is an outlier. I don't want the box plot to be in this direction. Horizontal equal to true. So you can see in a box plot, this is the distribution of the data, but there is an outlier, right? So always a box plot separates an outlier. What is meant by an outlier? Anything which is extreme maximum or anything which is extreme minimum, we call it as an outlier. So this is nothing but our outlier, which is causing so some disturbances in our data. So I separated it and I parked it outside. I call them as outliers. So box plot can showcase or it can witness the outliers, whereas your histograms, they never show the outliers. They include them in the visualization. Even if you see it, you can see the histograms are included. The outliers are included in my visualization. So we looked into choreogram, we looked into box plot, we looked into histogram, we looked into aggregate command, summarize command, we looked into some of the scatter plot, so some summary, right? All these commands, we looked into it. So before moving ahead, so now after this, after I just want to plot a graph between cylinder, we already looked in. I'm just cleaning this stuff, right? I want to see what is the plot command. I can use a question mark so that I can read the theory about what is the purpose of a plot command. I want to plot a graph to empty cards based on cylinder, and I want the dot type to be a dot plot and the color need to be red and the y-axis limit need to range from 0 to 30. If I run it, yes, the y-axis limit is ranging from 0 to 30 and it is a dot plot and the color is red. I don't want a red color, I want a blue color. You can get it into a blue color, right? So in the same way, I think whatever the data you have, I want to overlap one over the another. So I want to plot the graph between cylinder and miles per gallon. So to differentiate it, I'm using two different colors. So let me run this command. I got it in a red color. On top of it, I want to add one more graph, the miles per gallon, which is ranging between 0, so something around 35. So you can see the least amount of miles per gallon ranges from 10 to 35. So I feel it the y-axis limit, if it is 35, that would be great. So I plotted it, it is for 35 and I plotted a line graph. So everything is within the plot, right? So with the help of right, so with the help of this particular plot, what I can do is I'm able to convert this particular colors into red and into the blue, right? So I'm able to overlap one plot over the another plot. This is what I can do it with the help of box plot, right? Able to I hope everyone is clear, right? So let's get into one more thing. So I plotted this in a similar direction. I want to plot a box plot where the column, the color need to be yellow in color, and I want the plot of a box need to be in a horizontal direction. Let me run it. Yes, I got a box plot which is in horizontal direction and the color is yellow. I want to change the color. You can convert it into red, right? So as similar. Now, just the plot doesn't suffice. I want to give a title to it. I want to give a name of x-axis and y-axis. So I would be using box plot. I want to plot it for miles per gallon versus cylinder. So these two things are from empty carts data. So the main is the title, car mileage data, and x lab is number of cylinders, and y lab is your miles per gallon. Right? Let me run it. I got this. I want to export this into my system. I can save as PDF or into PNG, and I can save it so that it would be in my system, right? So as same as like what you are doing, you want to do it for even a box plot. So I want to create one more box plot. So good morning, goodbye, and hello, right? So this is how we can customize our visualization. And for better visualizations, we use different libraries in upcoming e-learning, like ggplot2 and all this we would be looking in, right? So when we are looking into this particular box plot, we can see miles per gallon and empty cars and a particular stuff. And after this, I want to show you, I want to import one more data, which is nothing but iris data. So before getting into this, I hope all this about stuff are clear. I'm just recapping it before moving into one more example. So we looked into summarize, we looked into aggregate, we looked into choreogram, we looked into histogram, box plot, we looked into various different plotting styles with plotting customizations, and we looked into saving a plot into image into our system even to check it. So I would be showing you up. So in this way, we can do this particular activities with our visualizations. So before looking into some more visualizations, so we can import one more data called as iris dataset. So this is our iris dataset, which is nothing but a flower dataset. So in the flower dataset, which contains sepal length, sepal width, petal length, and petal width, and the species, right? So I just want to plot this particular visualization. So if I say plot of iris, so it would be plotting for entire dataset. So it is going across sepal length, and you can see sepal width. This is the graph. So sepal length and petal length, this is the graph. Sepal length and petal width, this is the graph. So always we need to look in this direction. Sepal length is on y-axis, petal width is on x-axis. So sepal length is on x-axis for this plot, and petal length is on y-axis, sorry, x-axis for this plot. So sepal length is on y-axis and petal width is on x-axis. So in this way, we would be plotting the graph for entire data set, right? So by doing it or by plotting it in this style, we are able to grab everything in a single stretch. If you want, you can save it in your system and you can use it in your PowerPoints or anything else. No, I don't want to do it in this way. I just want to plot a separate set of visualization for each and every column. You can plot it in this way. So species versus the particular sepal length, or I want to plot a graph only for sepal length. It's going to be a particular scatter plot like this. So I want to plot a graph only with sepal length where I want the type to be a line graph, right? I want to plot a graph to sepal length where the graph need to be a histogram, right? So I want a bar plot. You can get a bar plot like this, right? So by using, these are the various customizations we can do it for a single plot command. We can pass a type, we can pass the particular different types and all this. All right, so I don't want a normal kind of stuff. I want a pie chart. So in order to get a pie chart, we can use it in this direction. So the amount of proportions of the data on Setosa, so number of rows on Virginica, and let number of rows on versicolor, we can see it with the help of pie chart. So I don't want a pie chart, I want to plot a histogram. You can do it in this direction. This is the frequency distribution plot using histogram, right? So as well as we are doing with histogram, we have one more called as box plot. So in a box plot, you can work on it in this direction. So we already looked into it. So there is one more command, we call it as pair of MF row. So which is nothing but visualization parameter or graphical parameter. So you are defining the sizes as one row and two columns. So whatever the visualization window you have, MF row is nothing but your visualization window. You are splitting that into one row and two columns. I need to execute it and I want to plot a graph. Now you can see we are able to plot two visualizations at a stretch, right? If I want, again, I want to plot two more, I can change it. Or in the same, I want to plot four visualizations, you can give it as 2, 2, and plot 1, plot 2, plot 3, and plot 4, right? So it is like a dashboard, and again, you can save it or you can export it into your system, right? So I done the same MF row, like I want to add some title, and in this way, like 1, 2, the first plot is the title, and second one is a normal visualization. No, this is a white background. I don't like a white background. You want to change it to a blue background, you can, and you can plot a box plot. This is how we can change it, right? So on the same blue background, I just want to go with the dimensions, 3 rows and 2 columns. So the size may not be sufficient, so I'm stretching it, and I am plotting various histograms and the color styles, right? So this is how we can do it for better visualizations. So you can define the background color, you can define the color of a plot. So you can see here, you can pass the different color palettes we have, right? It's up to you whatever the type you want. You can give the title, you can change the title. VA depth is nothing but your data set. So you're splitting that into multiple dimensions like a dashboard, right? So this is how you can build some visualizations. These are some basic visualizations in our art studio. So as well as in the same line, we have xbin, which is like hexagonal plot, the same plot, but the plot going to be in hexagonal dimensions. That's it. So if you want, you can see this hexagonal dimensional plot as well. So even other than this, we have best visualizations. We would be using it with ggplot2. There you get more beautification, more coloring, and all this, right? So I share even this script with you. You can work on it, so you can practice it. So it's going to be so good hands-on for all the visualization. So don't work on this particular data sets. When you're work on your own data sets. Thank you so much. See you again in our next e-learning session. Column now we created based on the row names of a particular data set. That's what we said. So create a column called as state with row names is nothing but my data, and you are adding it with the existing my data, so that we are able to create 5 columns: state, murder, assault, urban pop, and rape. So after doing this, I created, so we can say like what exactly we done. We created new column based on row names, right? And we joined it. And in similar direction, we have one more command called as gather, right? So I want to gather my data, key equal to names and value equal to values. So I'm taking state, what exactly it is doing. Let me print it and let me show you. So what exactly meant by this? I want to convert the rest of in this particular rest of the particular data set. I want to create, or I want to make entire data as a row wise. I'm just reshaping the data. So based on the state, I don't want to convert this state. I want to make only a single column called as state. And I want to convert murder, assault, urban pop, and rape into names. So the column names are under names, and values are nothing but each and every murder: 13.2 Alabama, Georgia 17.4, Maryland 11.3. In this way, we are able to gather the particular data. Means it's a kind of a reshape or transpose we are doing to our particular data set. So but we are not transposing our state column. In case you can see here minus state, I don't want to use it minus state. Let me remove this minus state and let me run it. So when I execute it, and if I look into my data, You can see there are only two columns, names and values, and entire data is shaped towards transpose to one side, right? In the similar lines, I want to convert names and values only for two columns called as murder and assault. So let me print that data set, which is nothing but my underscore data 2, and let me run it. Yeah, so you can see here, so I'm not shaping state and urban pop and rape, but rest of the columns like murder and assault I converted into two separate columns, where murder and assault are converted as a discrete data, and arrest estimates, the values are converted into the particular numerical data. Where exactly we can use this in case of the data, for example ship mode, you are able to see there are three ship modes: standard class, first class, and some other class ship mode like second class ship mode. So there are three different columns, but you don't want three different columns. You want to make a single column with respect to called as type of ship mode and the respective sales or the respective quantity. Then the gather command going to work pretty well for your data set. And in the same way, we are able to see the another command called as spread. What exactly meant by spread command? I want to pass this particular my data to, and I just want to see what exactly is happening, my underscore data 3, and let me run it and see. Yes, so whatever the data, I converted it, I renamed back to its own respective columns. If you're able to see this, right, I pulled out this data to which contains arrest attribute and arrest estimate. I'm able to make it back again. So in case if your data contains three different classes, right, in a single column like ship mode, like first class, second class, and third class, you want to make it as three different columns, you can use a command spread, right? So as well as we have one more column called as one more command called as unite. So in order to join two columns into one column, we would be using unite, and let me see what is present in unite, my underscore data of 4. And you can see murder and assault has been converted as a single column with a separator is nothing but hyphen, sorry, underscore, right? Unite is used to join two different columns. And as well as I'm able to see separate command. So where exactly you are able to find, so my separate my underscore data, I want to separate what data for, so murder result, and let me run it. So it is throwing me with an error. So let me see exactly data 5. So it is unable to do it. Why? In the sense I used a separator full stop, but it is not full stop, it is underscore, right? Let me open my underscore data 5. So now you can see it got separated. So unite is used to join and separate is used to separate it. For example, you were able to find the data in your various columns where exactly the values are ranging from this to this, right? Those kind of information, it's better to split it based on a separate command, right, into two different columns. In order to execute this filter command, I'm using a new data set. I think you are aware of it, which is nothing but iris data set, which is nothing but a flowers data set. So I want to filter the entire iris data based on sepal length is greater than 7. If the sepal length is greater than 7, only those values based on this column I want to filter it, and I want to store it in data 1. Let me run it. Let me open data 1. Yes, so based on sepal length greater than 7, I'm able to find nearly 12 columns, right? Sorry, 12 rows. In the similar lines, I want to filter the iris data based on petal width if it is equal to 0.2, and I stored it in data 2. You can see this. So whatever the values, nearly how many, there are only 29 objects which are only with only petal width equal to 0.2, right? So I want to know overall in 150 rows of iris data, I want to know distinct rows, and you can see one row is a duplicate format. That's the reason we deleted that one duplicate row and we captured 149 distinct rows in data 3, right? So the help of a distinct command, we are able to identify only the unique rows rather than going with duplicate rows. So in the similar direction, what we are doing is I want to create a sample underscore fraction. So for a iris data set means I want to pick a sample of 50%, replace equal to true. Let me run it and let me open data 4,
right? So when I'm looking into data 4, there are 75 randomly selected rows. You can see that I want to use distinct command. So data uh, underscore d is equal to, so distinct of data 4, right? So you are able to see data D. Where is data D? It contains 65 so objects. So here 75 are the sample we picked, but you can see there are duplicates of 10 rows. Let me convert this replace equal to false, right? Let me see it. So I stored it in data 4. Let me check for the distinct. So there are 74 and 74. What the reason behind 74 is, so only one duplicate. The reason is we already have one duplicate in our iris dataset. So by using replace equal to false, you may not be generating a duplicate values. If you use replace equal to true, you're going to generate the duplicate values, right? So as well as what I done it, I'm doing it for rather than, you can go with a fraction like 50%, or you can go with a number of rows. I want only 10 rows and I want duplicate values. I stored it in data 5, right? And I want to slice the data from 10 rows to 15 rows. I would be using a slice command. So with the help of data 6, I slice the data from this row to this row, right? So I want to select only these three columns from iris dataset. I would be using select command, and I store that information in data 7. So go to data 7. Yes, I can see sepal width, petal length, and species, which is nothing but we are able to select the particular data. So I want to select the data from iris which contains only dots, which is nothing but the full stop. Let me go to data 8. You can see that there is no species. Why? In the sense, in a column, wherever there is a dot, I picked it, right? So for that reason, I would be going with again this particular date again contains dot. Again, the data, when we are using, every data contains only dots, right? We are picking only the float values. So I want to summarize iris dataset based on average sepal length. Let me run it. Let me go to this. So we are able to create a single column, which is nothing but the mean of sepal length. So summarize each. It's gonna convert the entire data into, so all the 5 columns we are able to get the summary for all the summarizing report for all the means for all the columns, right? I want to know count of the iris dataset based on species with respect to sepal length. Let me go to data 11. You can see there is a count of setosa nearly this. All the values are summed up. Versicolor, this is the sum. Virginica, this is the sum. We are able to sum it. I want to do group by of iris data based on species, and I stored it in data 12. So I'm able to group it based on setosa, versicolor, and this. So in the similar direction, I want to ungroup the data. I think it's already the data is grouped, so we can't see much difference between grouping and ungrouping. You can try it on your data sets. I want to mute it. I want to join 2 columns and I want to add it to my iris data set, and I call it as sepal. So let me open data 14. I'm able to see a new column called as sepal, which is an add-on and addition between 2 columns, right? So mutate each, I want to know the minimum rank. So let me go to 15. This is how we are able to, based on the ranking, we arranged the entire data based on the ranks of each and every value. So these are some of the modeling commands. We can do it with dplyr, and on the next e-learning session, I show you how to deal with joining with the respect of, with the help of dplyr command, right? Thank you so much. And x1, x2, x3, and 1, 2, 3. And inside B, I'm joining with A and C. So I got A and C, where x1, x2, x4, AA, BB, and CC. Now what I need to do is, there are entire A and B creates one data set, which is nothing but which comprises of 3 columns, A, B, and C. And if you observe it, in whatever the values which are present in A, in column A, and whatever the values which are present in A in column B, both are different, except last, I think rest of the things are same, only except last particular value. So now we call them as nothing but whatever the joins we are looking now, they are nothing but we call it as SQL joins. So what is the major purpose of SQL joins is, in SQL joins, there are different types of join. One is left join, right join, inner join, full join, and semi join. So when you are doing joins in SQL, you need to make a statement about, I want to perform a join between A and B. So in A and B, what is on left side? So data set A is on left side. So you want to do a join on a specific column. What is a common column between all these two data frames? So column A is the common data set or column. So I want to perform a left join. So I got a left join over here. You can see column A, entire data set from A side. So when you are doing a left join, entire data set from A and only the matching fields from B. So now entire data set is x1, x2, x3 and 1, 2, 3. So what is the matching field? X1, A and BB, but there is no x3 in column in data B, so it is made as a null value. So for the same data set, if I work on this one, if I do on right join, entire data set from right side and matching fields from left side, you can see x4 is present in column B, data set B, but inside your right join, I think when you are doing with the column A, in data set A, there is no this particular x4. That's the reason when you are doing a right join, so how exactly you need to care is, I want entire data set from left side. Means if you are missing any customer, that's not a problem from right side, but you want entire data set from entire value or entire information from data set A. So what you'd be doing, you'd be working on left join or a right join. So I don't want any null values, or I don't want any missing values. I just want a common data between both the data sets. I would be going with inner join. So when you're looking into inner join only, we are able to see two rows. Why? In the sense x3 is present in left data set and x4 is present in right data set. So I don't want to create a null value, so I would be going with this sort of inner join. And I know I don't want any inner join, I want to join entirely, then I would be going with full join. So when you're looking into full join, you can see x4, x3 both are added up, right? So you want entire data set irrespective of null values, you can go with full join. Or there is one more join called as a semi join. So when you're looking into semi join, you are going with only the common columns, you are not even joining with not only common rows, common columns as well. So C is not present in A data set, so that's the reason we picked only common columns between both the things. That's the reason I'm going with semi join. And in similar lines, we have one more join called as anti join. So whereas in anti join, only the particular common or we can say like something unique data from left join, we are able to see it here, right? So these are the different types of joins we can work on. In similar lines, we can work on some of the union operations or set operations. So I'm creating again two different data frames, E and F. So where in E we are able to see ABC and 1 to 3, and where in F I'm able to see CBD and 3 to 4, and I want to do intersect of E and F. So let me open inter common data between both the things, and in as well as I want to go with the union join between E and F. So when I'm looking into union, I can see everything is joined, we call it as union. I want to go with set difference. What are the difference between both the things? We are able to see it in set difference, only D and 4 are different. As well as we need to join two rows, I would be using bind rows, so that if you are able to go with rows, you are able to add it up with the rest of both the data sets got joined. In order to join the rows, we use bind rows, and I want to do bind the columns, so I'm able to bind the entire columns in this format. So this is how we can perform some of our data cleaning with respect to dplyr library, so which is very good. I think if you have some data sets, you can work on your data set, so this is going to give you more understanding and broader picture about data joining, more or less like on left join, right join, inner join, full join. So for explaining you in a simple note, I just want to go with a small Excel sheet, and I just want to explain you the left join and right join in case if you feel it pretty complex. Let's imagine. there is a SQL table which contains customer name, and there is one more called sales, and one more thing called as profit, and in this is called as dataset 1. And in similar direction, I want to create dataset 2 where it contains again customer name, but it contains some ship mode and product. Right, customer name is A, B, C, D. Sales, I'm writing it as 1, 2, 3, 4, and profit is 10, 20, 30, 40, some random values. Again here A, B, C, E, D. Right, ship mode is first class, second class, first class. Product is AA, BB, CC, DD. Right. So when I'm performing left join, these are called as SQL joins. So entire data set from left side, entire data set from left side, and only the matching field. So customer, ship mode, and product. So here this is null value, this is null value. Why? In the sense we have customer A, B, and D, but we don't have C inside this D2 column, so these two things are null values. If I say right join, if I work on right join, so entire data set from right side, right, and only the matching field, the sales and profit, going to be where this going to be null value, and there's going to be null value. Right, so this is how we are able to create joins. In case if I say inner join, only the common columns. If I say outer join, everything would be joined. So this is how we work on SQL joins. So this is one of the important technique and very important when you are going with real time. When you, in order to join two different data sets, I think SQL joins are very important. And with the help of DPLYR library, we are able to do these sorts of joins here. Right, so I hope this script you can try it with some of your data sets and try to work on, and any queries or so, right, you can look into the script and you can clarify them. Thank you so much. See you again in our next e-learning session
with our DPLYR. So in this session, we go through ggplot2 some few snippets of commands. So let's walk through the script. Here, one of the familiar library when we are going for visualization is ggplot2. It's very good at the visualizations and all this. We are able to get very good amount of user interactive visualizations. So for that, I'm just loading my library. I already installed it. So if you want to install any ggplot2, in case if it is not present in your system, you can use ggplot2 install.packages so that you can install your library. And I just want to load my ggplot2. I loaded it, and before doing it, I just want to clean my console, and I just want to allocate some space to the visualization so that we can see. I just want to load it, and I want to load the diamonds dataset, which contains 53,940 observations and across 10 columns. I want to view my particular dataset, so how exactly it is looking like. So you can see there is a carrot cut type of cut, whether it is an idle cut or a premium cut or a good cut, very good cut, in this way fair. There are different varieties, and you have color like EEIJ, so on and so forth, and the clarity, depth of the cut, so table, price, so on and so forth. In this way we have different set of parameters. I want to plot a graph between cut across cut. I want to plot for entire diamonds data set. So this is how the graph is looking like. There are overall this varieties of cut like fair cut, good, very good, premium, and idle cut. And idle cut is majority of the people. And what are the data we have? Majority, nearly more than 20,000 of diamonds are related to idle cut. And even you can see nearly 13,000 or from premium cut, and from very good I'm able to see nearly 10,000 above, like 14,000 or something like that. And fair cut is hardly in thousands or even in hundreds, and good is nearly 5,000. So we can understand overall there are 5 different types of cut by looking into this command. Even it is pretty interactive than your normal visualization. I want to see how the carrots are ranging. So this is the distribution. We call this plot as normal distributed plot, but there is a skewness. You can see there is a bit of skewness. So if there is a skewness, your particular model going to be majority of the carrots are between this range 0 to 2. So this is what I can understand it through the histogram. And it is a skewed visualization. And in case if you are going with any of the linear regression or logistic regression for this diamonds data set, your algorithm can learn very well with this particular carrots, this range of carrots. Why? In the sense majority of the data is falling at this particular range. So I can define bin width. Bin is nothing but the individual split or the scaling, the interval gap between one histogram to another histogram is nothing but the bin. I just want to see the bin. So it is very fat bin like 1. So you can see here it's pretty we can see the less amount of distribution. You can notice it. I want to reduce the bin to 0.5. It is very thin now. You can see majority of the carrots are between 0 point less than that range 0 to between 1. Majority of the data is falling. I want to go even minute bin like 0.01. You can see this is how the distribution of data is looking like. So across 53,940 columns. Right, always bin is nothing but the interval gap between one histogram to another histogram. We call it as a bin. So now I want to plot a graph for table column. So let me go to diamonds. You can see table here. So based on this I want to plot a graph, and I want to provide x-axis limit need to range between 50 to 70 and a bin width equal to 1. So let me plot it and see. Right, so this is how we are able to plot it. So we are able to plot a graph between 50 to 70, right? So with a bin width of 1. Even if you want it, you can reduce to 0.1 and let me plot it. So this is how you are able to see if you reduce the bin width to 0.1. So normally as a default we made it as 1, and even you want to provide both the bin width, x-axis limit, and a y-axis limit, you use plus command. So let me plot it. This is how even you can see the x-axis limit is ranging between 0 to 50. Sorry, y-axis is ranging between 0 to 50. X-axis is ranging between 50 to 70. So with a bin width of 0.1. So I want to plot a graph between, I want to understand about my data. So based on carat of the diamond and based on the price. So let me see how the distribution is happening. So I want to plot some smoothing curve over it. So GEOM is majorly used in order to provide the smoothing and in order to provide a fitted line. So this is nothing but we call it as smoothing line. So we can plot it by using GEOM command or argument out of it. So this is how the distribution of the data is as your price is increasing. So you can see the carats are also increasing. So based on the prices, you have different levels of carats. If the price is very high, I think you can get even very highest carat levels. You can see this is how the price and the carats are distributed. So in the similar lines, I want to provide the color. I don't want to provide any fitted line like this, but based on the price and the carat, I want to plot a red color graph. Let me plot it and let me see. Right, this is our red color. So I want to plot again. I want to pass one more red color. Right, so again I'm passing alpha inverse, I in the sense inverse color. So 1 by 10. I'm reducing the transparency majorly. right? So transparency, I added more transparency, 1 by 50. The transparency even more added up. I just want to go 1 by 100. Even you can see there is more transparency. Even you can go with 1 by 250, even there is more transparency, right? So you can see it. So this is how we can plot some good visualizations by using ggplot, right? So this commands, even for your assignment, I added some additional script in your script folder so that you can work on them. And these are some, this is how I'm not sustaining more time on the visualizations. Why? In the sense we already spent some good time on all the visualization in our first session. So that's the reason you can go through ggplot and you can play around the commands. There are some more commands where you can work on it, so it would be a good hands-on for you. And the ggplot is something where we use a majority of the time in real time. You can check this particular ggplot2 package and you can work on some data set, use with your own data set and try to play around all these commands, right? And to get a documentation about the ggplot2, you can use this, you can go to the path and you can search for ggplot2. And if you are able to go here, you can search for, yeah, you can see this is all the stats related to ggplot2. You can read about it. So majorly ggplot is written in your R programming. If you want any cheat sheet, you can go through this cheat sheet of ggplot2. They are already preloaded. You can get this cheat sheet. And if you want to get any visualizations, I think you can use this and you can copy it and you can paste it and you can get some visualizations. Even if you want any tutorial, you can search, browse. This is extension, any tutorials here have they provided. Let me see. This is the book. This is not required from Amazon. I'm looking into any, I think they unveiled the tutorials, I think so. You can just whatever the commands, you can get all the commands from this cheat sheet, and based on the cheat sheet you can work on it, so it can guide you on all the visualization commands. So what exactly each and every command is doing, each and every function is doing. You can look into this cheat sheet, the position adjustment, the coordinate adjustment, the faceting, the labels, the legends, the zooming operation, every command you can work on it based on your time frame. You can download this cheat sheet and you can play around. So if you want, I would be putting down into the particular script tab where you can access it. So it can help you to play around all these commands. So what is GUM? So all these things you can look into it. It's going to help you for better utilization of your visualizations and to build some good and very interactive visualizations. ggplot2 always going to be one of the best stop you can play around, right? So I hope that we just looked into the basic intro of our ggplot2 command, so you can work on it in our later time. So I think our major thing is to work on data preparation. On our next class, we work on majority of our data preparation using our studio, using advanced data preparation and all this, so that you get more hands-on on it and it would be more helpful for you as well. Thank you. So welcome to our new e-learning session on data preparation with R Studio. So in this session, we would be working on some of the preparation techniques and cleaning techniques from we collect one data set and we try to work on it. Let's walk through our R Studio, how exactly we work on. So for that reason, I'm importing one of the file from my system. I think we already visited, I'm not sure, I don't remember exactly, which is nothing but our fraud data.csv. So let me go to that. Yep, I selected it. Let me open it. I want to check the dimensions of a data. So dimensions of fraud data, what we imported. Let me run it. So there are overall 11 rows and 9 columns. So I want to know the class. Yes, it's a data frame. So class is used to check
the data frame, or to check the data type of your variable, right? We use class. And I want to plot a histogram for state column. So I can see majority of the states are ranging between 0 to 10, and from 10 to 20 you can see different state levels. I want to plot even a histogram for fraud data. So this is, I'm commenting it. So plotting histogram for state column, and I want to plot a box plot. So let me plot it and let me see. Yes, this is the box plot, and I feel um, it's like normal distributed. It's not exactly normal distributed. If it is normal distributed, the tails need to be even more. It's not normal distributed. Its overall distribution is okay. I want to check, is a character object or not. Customer ID, I want to see head command, fraud first 6 rows. I just want to check it. To check first 6 rows, I would be using fraud dot, sorry, head of fraud data. So these are the first 6 rows. I can see customer ID is a numeric data. I just want to see, is it a character? Is character. So let your customer ID. So it said false. It's not a character. So absolutely, it's a numeric data. I just want to use is numeric to check if it is numeric or not. For that reason, is numeric of fraud dollar customer ID. True, it's a numeric. So I want to convert that into as character. So as character is used majorly to convert data into character format. We use as character. So I want to convert this customer ID into as character, and I'm storing into fraud dollar customer ID. So let me run it. So let me see whether is it is character. It's true. And let me check for is numeric. I don't think so. It's going to be a numeric. Why? In the sense we already converted that into character. It's not a numeric. It's false. So I just want to see again head of fraud dollar customer ID. So these are the first rows. So if you are adding a double quotations to a number, it's going to be a character. I can see here, and I want to go to the first row of customer ID, and I want to replace that with hi. So again, I want to use head of fraud dollar customer ID. So you can see there is a new thing. One got replaced with hi, and I want to convert that particular hi into two upper. So converting data into uppercase. I want to convert this particular data into uppercase. So let me see it. Fraud dollar customer ID. You can see it got converted into uppercase, which is nothing but hi. And I don't want this into uppercase. I already looked into it. I want to convert that into lowercase again. So here, let me write it. Converting data into lowercase. So you can see here hi is converted into lowercase. Now I want to install a new library, which is nothing but string.r. So if you want to install it, you can use install.packages of string.r if you want it. It's already present in my system, so I'm loading it. So let me load this library, and I want to go to third index position, the row position, and I want to store hi, how are you into customer ID. Let me print head of fraud dollar customer ID. So you can see on the third position, it got replaced with hi, how are you? I want to replace, so it's a mistake. I don't want this as hi, how are you? I want to replace this with Mr. and Mrs. So str underscore replace, wherever there is fraud, go to fraud dollar customer ID, and wherever there is hi, how are you? Replace that with Mr. or Mrs. Right? And let me check it. Yeah, it got replaced. So absolutely. So when you would be using this replace command is, so this is only not the position where you have hi, how are you? There are multiple positions. So to replace all the multiple positions at a stretch, you can use str underscore replace. So to replace any format, whatever you can replace anything using replace command, right? So across data set, you can replace it across data set. So in similar direction, I just want to checking null values, right? So in order to check null values, I'm using isNA. Go to fraud under card holder. Let me run it. Yeah, you can see there is a true and there is true. And I want to plot first few rows head of, I want to use tail. I think in the last few rows, you can see I have this. So fraud dollar card holder. You can see few rows you are able to see null values. I just want to omit it. So, and let me print it and see fraud. I want to use tail command of fraud, just entire fraud data. I want to plot it. So but you can see there are null values, they are not omitted. So the reason I'm not storing it anywhere, so I want to store it in fraud and I want to run it. Now let me print fraud. I think, yes, they got omitted. You can't see any null values here. Everything got deleted. So this is how you can treat your null values using this commands. So this is how we try to prepare. Even we looked into some more data cleaning commands on our initial classes data preparation. So by using these commands based on the data set, you can work on any sort of challenges by using uppercase, lowercase. If you want, you can replace them. If you want, you can convert from one data type to another data type, like is numeric, as character, as factor. In this way, whatever the format you want, you can convert it. You can delete the null values. You can check for the null values. Everything, entire operations you can work on by using all this data preparation commands. So we discuss more data cleaning and data preparation with respect to our next modules using linear regression or decision trees, and all this based on the algorithm we try to perform the cleaning operation. So with this we try to close up the entire our programming, the advanced data preparation module. We are closing it, and on our next e-learning session we start with SQL. So MySQL database, how to install them, how to create some data, how to check the schema, all these operations we would be working on. So see you on our next e-learning session. So try to perform the script and everything, and make sure that before getting into anything, try to make sure you are having some good concept and good practice on our programming.
E-learning session on data cleaning using regular expressions. So we discussed on various data preparation commands, but we never looked into how to deal with regular expressions. Just we looked on replacing some strings with strings. In this way we looked on, but we never done with dealing with regular expressions. So when you're dealing with regular expressions, anything which is falling under like tabs, to replace the spaces, to replace your lower cases, upper cases. So to replace the data between A to Z, small a to Z, 0 to 9, some special characters, right? Everything comes under regular expressions. So to know more about it, if you want to document anything, right, if you want to read about documentation of the regular expressions, you can just look into this. So regular expressions in our programming. So if you want to master based on the timing, if you want to get any time, you can see all the regular expressions which are used in R. So You can see these are all the type of regular expressions what we are able to see. So alphanumeric, the data we can say like alnum, so which contains both alphabetical and numeric kind of data. If you are able to find both alphabetical and numeric, like 0 1 a 2 3, like your certain scanner id, or you are having certain order id which contains both alphabetical and numerical, you go with alnum. In case if you want to deal with only alphabetical characteristics, you use alpha, right? ALPHA. Always we need to use this with the command called as gsub, group substitution, or any of the commands. So if you are dealing with again in alphabetical, you are able to see two different types: lower cases and upper cases. So in alphabetical, you can see lower in the sense lowercase, and upper in the sense uppercase. Means I want to treat only lower cases in alphabetical and only upper cases in alphabetical data. I can deal with even those here. And parallelly, I want to deal with blank spaces, blank characteristics like space and tab, and possibly other locally dependent characters such as non-breaking spaces. So I go with the blank. And I want to deal with the ASCII characteristics like codes, octal codes like 00 through 037 and 177. Delete in other character sets. These are equivalent characters, if any, right? To deal with any ASCII characteristics, you need to use CNTRL command for regular expressions. And there is as well as one more called as digits. If you want to replace any digit between 0 to 9, means it can be one digit or it can be two. Within 0 to 9, we can replace using digit regular expression. If you want to deal with any graphical characteristics like alphanumeric and punctuations, again in graphical characteristics you have alphanumeric as well as punctuations. You can replace them. So print, so printable characteristics. If you're having anything, you can use colon print. If you want to replace any punctuations which deals with exclamatory marks, single quotations, double quotations, dollar, so whatever the punctuations, you are able to see it in your code, in your thing, you are able to replace it with space with your punctuation command. And if there is any characteristics like tab, new line, vertical tab, form feed, carriage return, etc. and etc., you can deal with space. And if you're having anything which is related to x digits, something like hexadecimal digits, you can deal with your this particular x digit kind of regular expression. So these are the different regular expressions we are able to see. So based on the usage and based on the data you are having in, so you can replace them. You can replace the regular expressions, right? So regular expressions are something what you are able to find it frequently in your data. We call it as regular expressions. So you are able to deal with them. So now when you are dealing with this kind of regular expressions, one of the very important stuff with regular expressions is nothing but, so when you are dealing with any of the regular expressions, so we need to deal majorly with upper cases, lower cases, and all this kind of regular expressions. Let's deal with how to deal with all this regular expressions. So let me go back to my art programming. So I just want to deal you with one of the examples. So there is an automobile data set. So I just want, let me clean it before going with data set. I just want to read a CSV file by file.choose. It is present in my data set like automobile data. This is automobile price dataset, which is raw. I imported it. I just want to check for dimensions of automobile. So there are 2,205 rows and 26 columns. And I need to check some EDA, exploratory data analysis. So I need to know the describe command. So describe is nothing but summary of automobile dataset. So I can see here when I'm using automobile dataset, okay. You can see I want to store it just to cross check. Overall there are 26. I need to get a summary for all the 26. But when I'm storing it inside A and when I run this automobile, I'm able to see. So summary, it contains, yes, there are 26 columns, but different based on the data type. You can see here there are some question marks in price, right? And even this is a string data. Price is a string data. And can I check info? Let me use any info command if I have. Info, there is no info, all right. So this is numeric. Okay, this is peak RPM is not a numeric. It is like repetitive data. How many times each value repeated. Horsepower is also uh, not a numeric data. It is a kind of 141 rows. There are something different in it. So I'm able to see. I want to write it down from the starting. So I want to go from the start. So from symboling, yes, symboling is numeric. So string data normalized dot losses, and even make is also, why this make is different. So make is like Toyota and all this. Okay, that's okay. It need to be alphabetical. That's right. So fuel type, yes, it need to be alphabetical. Aspiration, yes, it need to be string discrete data. Number of those, there is something like question marks I can see. And body style, all right, wagon, sedan, and all this. So drive wheels, yes, it need to be same discrete. Engine location, yes, it need to be discrete. Wheelbase, yes, it need to be continuous. Length is continuous. Width is continuous. Height is also continuous. Curve weight is also continuous. So engine type is discrete, yes. Number of cylinders is also discrete. Engine size is continuous, and the fuel system is discrete. Bore is also, it's a discrete quantity. Bore type like 0 3.62 bores repeated 23 times. All right, it's a discrete, but it's a numeric. Bore is numeric, but why discrete? Numeric, but why discrete is the question mark. So next, stroke, it's also stroke is discrete, but not exactly. Compression ratio, horsepower. Horsepower is numeric. It need to be, horsepower is discrete, but that's not true. It should not be discrete. And I'm able to see peak RPM. Peak RPM, peak dot RPM is discrete. Why? It should not be a discrete. And miles per gallon, yes, it's numeric. City miles per gallon and highway miles per gallon, that's good. There is a difference. Price, oh my god. So price is discrete. Why? It is discrete. All right. So this is what I'm able to get it through this describe command. Through summary command, I just want to deal with normalized at loss. There are some question marks. So here I'm able to see peak RPM. I just want to use. So here I just want to go to automobile dollar. So peak RPM. So equal to, so as dot numeric. So peak dot, so I need to automobile dollar peak RPM. Yes, it executed. Now let me search summary. So automobile. So if you are feeling bored every time to write it, so just I want to give the column name summary of peak.rpm. it gonna throw you with an error. Then you need to use a command attach. Attach is used in order to attach your data set, so that no need to use the dollar symbol every time. And I can run this directly now. Yeah, now I'm able to get this peak RPM in a numeric format. So in the same way, I just want to deal with what else is discrete. Horsepower is discrete. Why horsepower is discrete? So automobile. So I can say like data preparation. I'm doing data preparation here. So again, horsepower equal to as dot numeric. So horsepower. Again, I just want to check for summary of horsepower. I got it. Again, horsepower, I converted it. That's good. In the same way, I just want to deal with horsepower is stroke is also discrete. Bore is so I just want to check it for what is that? Stroke equal to as dot numeric of stroke, and again summary of stroke. Yes, it's again I made it into numeric. That's great. Yeah, and in a parallel way, stroke I done it now. Bore is numeric, so I want to do it for bore. So bore equal to as dot numeric of bore. So summary of bore I done it. Right, again, what else you have? So bore is not numeric. So number of doors. So number of doors contain what? So bore, it's done. So after bore, stroke, peak RPM. So price, I just want to check price equal to as dot numeric of price. So yes, it's converted. So summary of price. Yes, we got the price is also converted. So in the same way, next one, price, you got it. Number of doors, equal to as dot numeric of number of doors, summary of number dot of doors. Yes, even it is converted. So I want to convert, so normalized losses equal to as dot numeric of normalized losses. Uh, summary of normalized losses. Yes, I got it. So just I want to see, let me head of automobile data. So when I looked into head, I'm able to see all the first few rows, but I can see some question marks in normalized losses. Even I just want to use unique. So again, I want to do some EDA. Again, EDA phase 2. So I want to use unique for normalized losses. So when I'm looking at unique of normalized losses, there are any question marks if I open. Okay, I'm storing it into the data. So I want to do this. So automobile dollar normalized losses. I just want to use unique of normalized losses. Yes, it got. If let me check head. Yes, we converted. You can see wherever there is a question mark, it got converted to one. So in a simple format. Right. I missed the storing. Again, I just want to do the storing for each and every, like bore or number of doors. So automobile dollar. Yes, I done it. So in the same way for price, I just want to store in the same column, dollar price. Even the bore, it may contain automobile, dollar bore. Yes, I converted it. Same with the stroke, automobile, dollar stroke. Yes, I made it. So automobile, dollar horsepower. Yeah, perfect. Absolutely, that's good. So this is one way. So when I'm looking at unique, I just want to go with unique of uh, automobile data. So you're able to see this is the unique thing for entire dataset for price. There are no question marks for highway price, nothing. There are no question marks and everything is pretty good enough. So this is what I can see or I can sense. This is one way of doing it, or there is second way of processing question marks in your data set. So we can say question marks or anything. So let me load this data back again, which is attach downloads. Right, again, I loaded the data. Let me check for the dimensions just to confirm. Summary. Yes, I got all the question marks back, or I can just. Yes, I got all the question marks back. That's good. Now, let me deal with this. I done with automobile. This is, I want to go with second way of data processing. So automobile, so dollar normalized losses equal to G sub, which is nothing but group substitution. G sub of, I just want to deal with double quotations, punct. I want to replace that with 0. I want to give auto mobile dollar normalized losses. Let me run it. So unique of auto mobile dollar normalized losses. So you can see it got replaced with 0. After replacing that to 0, why I'm done with 0? The specific reason is when you converted, so as numeric, when you're using as numeric, any special character can be converted to 1, but we don't want a special character to be 1. So if it is 1, I think if you are calculating mean of it, or if you're calculating median of it, the value is going to be something different. So if I replace it with those 0, so sum of values by number of values always going to be something nearly 0, right? That's the reason I'm making it into 0, so that I want to calculate mean of automobile dollar normalized losses. If you run it again, it is throwing you with a warning message. You got an A and Y in the sense. If you search for type, so is dot numeric, I just want to check is dot numeric. So automobile dollar normalize the losses. It is false, it's not a numeric, so I just want to use automobile dollar normalize losses equal to as dot numeric. So automobile dollar your normalized losses. So when you run it, it got converted. So again, let me check is dot numeric. So automobile dollar normalized losses. Yes, it's true. Now I just want to use mean of I want to calculate mean of automobile dollar normalized losses. So 97.6 is the mean. So I just want to right? So you're able to see here you got the mean as 97.6. So with the help of the mean 97.6, all right, so you need to replace wherever there is a zero, you need to replace that with its respective column mean so that you are able to achieve. So when you are able to replace its mean with their respective column mean, so wherever there is zero, you are replacing that with your mean of it. So this is the assignment you need to work on so that you would be getting an idea. It's very simple and easy. Just wherever there is zero, you need to replace that with 97.6, right? So this is how we can work with regular expressions. So you can, if you want, we can give it a try. So just as like I want to replace something like what exactly I want to do. I want to do G sub, right? So I want to go with G sub. So wherever there is zero G sub, or yes, wherever there is a zero, I want to replace it with 97.6. So from automobile dollar normalized losses. So it throwed you with an error saying that, so I use the square braces, I want to use parentheses. Let me use them, right? So wherever there is zero, it got replaced with 97.6. 97.6, it got replaced it. So I just want to store it back. So automobile dollar. So you were what exactly? Dollar normalized losses equal to G sub. So again is dot numeric of automobile dollar normalized losses. If you run it, it is false again. So again, you need to say automobile dollar normalized losses equal to, so your as dot numeric, you need to type, so automobile dollar normalized losses. So if you're able to do it now, if you check mean of your automobile dollar normalized losses, you are able to get the mean. This is how you can do it. In the same way, you can replace this with median, or you can replace it with mode. So anyway you can do it. So here so whatever the format you want, you can do it. So and even you can check the distribution. This is how, if you want to replace it based on your own specific thing, you can do it in this format. So in the same way, what I'm doing is so more with alphabetical. So there is automobile. So where I just want to deal with 1 comma 2. So what exactly 1 comma 2 deal with? So which is 97.6. Yes, absolutely the first position. I just want to replace with hi 0 1 2 3 and cap this. I want to run it. So now when you're looking into automobile, so same automobile of 1 comma 2, so it's going to print here with the same thing. I want to replace it, so automobile dollar normalized losses, so automobile dollar, so sorry, you need to use g sub of, so double quotation square braces. I want to replace only the digits, so digit, right? I want to replace that with what? I want to replace a digit with a question mark. So I want to pass a question mark in automobile dollar normalized losses. So let me print same automobile of 1 comma 2. Yes, all the digits got replaced with 1 comma 2. So this is regular expressions with digits. Right, in the same way, I want to deal with regular expressions with lowercase. Right, so again, I'm saying automobile dollar normalized losses equal to G sub of, so double braces, I want to use lower, right, comma, I want to replace wherever there is a lower, I want to replace with a capital A, wherever there is that, I want to replace it with capital in automobile dollar normalized losses. So again, let me print automobile of 1 comma 2. Yes, wherever there is a lower, it got replaced with the particular capital A. Now I want to deal with, so regular expression with uppercase automobile, or I can say simply automobile of 1 comma 2 equal to G sub of, I want to use square braces and I want to deal with upper. So wherever there is it, I just want to replace it with wide in automobile of 1 comma 2. So if I run it again, automobile of 1 comma 2, yes, it got replaced with the spaces, right? That's how. Again, now regular expressions with special characters. There are special characters. I just want to deal with automobile of 1 comma 2 equal to G sub. So there is one more command sub of, I just want to deal with, so punct. So wherever there is, I just want to replace it with 97.6 comma automobile of 1 comma 2. Again, if I type automobile of 1 comma 2, you can see only one question mark got replaced with 97.6. So the difference between G sub and sub is when you're going with the G sub, it deals with group substitution. So when you're dealing with sub, it deals with only substitution. Wherever it encounters a first special character, it replaces with 97.6, and rest of the special characters it replaces it doesn't replace, it stops the process. So the difference between group substitution and a substitution is it is an iterative task, G sub, and a sub is just it encounters the first one and it replaces the first one. We call it as sub. So I don't want to do with normal substitution. I just want to get regular expressions with special characters, group substitution. So automobile of 1 comma 2 equal to G sub of, I want to use punct itself. Alright, I just want to replace it with void auto mobile of 1 comma 2. Let me print auto mobile of 1 comma 2. So you got this 97.6, but it need to be 97.6. So again, I want to do with, I want 97.6. I don't want it. So regular expression with digit again. So auto mobile of 1 comma 2 equal to G sub. You can use even a, but sub doesn't work. So I just want to deal with the digit. I want to replace it with 97.6, comma, automobile of 1 comma 2, automobile of 1 comma 2. You got it. So 97.6, 97.6, 97.6. So how to deal with them? So you were able to see there is a digit, but you can take this as an example and you can work on. It's very simple. Again, you can take this as an example and you can work on it. So that's pretty good. We worked on one of the assignment on groups of regular expressions, which deals with every regular expression. We covered all the majority of the regular expressions. So this majorly deals with data cleaning. I want to save as. So data cleaning with regular expressions, right? This is very good. I think whatever the data you are dealing with, so you can work on in this way when you're, so you would be getting one complete overview if you're able to work on regular expressions. So majority of the real-time cases, we deal with regular expressions and treating them. There are different types, upper cases, lower cases, digits, punctuations, and all this. So you can try lower cases and all this. So you would be getting a great idea on it and you get a great hands-on. So try to spend time with your regular expressions. I'll be just providing you with the data set and the scripting. You can just play around, right? So that's great. You can work on it. Thanks for your for this e-learning, and try to spend some good time on your old sessions as well in the data preparation. So I hope if time permits, we can look into different ways of importing the data using R programming, or we can look on some more examples with different data sets, different crude data sets we can work on, so that you get some good picture on it, right? So well then, take care. So we can see you on our next e-learning session. Thank you so much. Stuff. So on the last session, we looked into what is meant by a supervised algorithm and what is meant by unsupervised way of learnings. So on today's e-learning session, we look into our linear regression, which is going to be our major portion of it. So when we are touching linear regression, there are two different overall in a regression models. There are two different types of linear regression. One is simple linear regression and another one is multiple linear regression. You can see here. So you can see the equation of a linear regression model where y equal to mx plus c, and when you're looking into multiple linear regression model where y equal to m1x1 plus m2x2 plus m3x3, so on and so forth till mnxn plus c, right? So before touching this, I just want to walk you through one of the example using this. So let me use my R Studio as a notepad rather than going with any of the Excel sheets. So let me use hash. So there are two different overall in a linear regression model. Let me draw it. Overall in regression models, there are two different types in regression models. So one is linear regression and another one is logistic regression. So you may be learning about logistic in our third module. One is linear regression, another one is logistic. So always we know the global equation of a of any machine learning model, y equal to f of x. So where x is independent parameter and where y is your dependent parameter. Right, where y is dependent and x is independent parameter. So if your dependent parameter is continuous, we go with linear regression model. Like continuous in the sense I want to predict the sales, I want to predict the miles per gallon, I want to predict the particular marks, I want to predict the horsepower, I want to predict the loan amount, I want to predict some insurance claim, amount of insurance I'm able to get. So on and so forth. So any of this particular continuous data to predict the continuous parameters, we go in with linear regression model. Means when the y, which is nothing but your dependent, if it is continuous, we go with linear regression model. And if the same y is discrete, if it is discrete, we go with logistic regression model. Right, so this is how we choose it. So if the y is continuous, you go with linear regression, and if the y is discrete, we go with logistic regression models. And where your x going to be, which x is nothing but your input parameters. So if there is only one input, so the basic equation of a linear regression is nothing but y equal to mx plus c. So where x is your input and y is your output. And whereas your slope and intercept, they're going to be your coefficients. If you are able to generate the slope and intercept value, you are able to say what exactly the y is, right? Which is nothing but your output. So if there is only one input, we call it as simple linear regression model. And if the y, if this particular equation contains y equal to m1 x1 plus m2 x2 plus so on and so forth mn xn. If it contains more than one input, we call them as multiple linear regression model. So the major difference between simple linear and a multiple linear is if there is only one input, we call it as a simple linear. If there are more than one input parameters, we call it as multiple linear regression model. And if the output is continuous, we go with linear regression. And if the output is discrete, we go with logistic regression model. So this is how we choose the linear regression or a logistic regression models. Now, before looking into linear, or a logistic, let me explain you a bit of math. So we looked into our schooling. Let's imagine x and y. So when x is 100, y is 10. When x is 200, y is 20. When x is 300, y is 30. When x is 400, y is 40. When x is 500, y is 50. So there is a question mark. When x is 600, what is your y? There is a question mark, right? So now when you're looking into it, if it is 600, to make a statement, we go with y-axis and we go with x-axis and we plot the line so that everything are falling straight. And if I draw a line which is connecting through all these data points, so I connect this here for 600 and I would be making a statement at y dash, which is nothing but 60. So this line contains an equation y equal to mx plus c from our very schooling. This is your m and this is your c value. So before looking into how to calculate m and c value, no need to do all this math as of now, but we want to look into some more theoretical point. So when we are calculating, in order to calculate m and c, there is one important thing which is nothing but we call it as correlationship.
So what is meant by correlation? So the relationship between two parameters, we call it as correlation. So the relationship between two parameters, we call it as correlation. So you can see here, there are different types of correlation. So as X is increasing, Y is decreasing, we call it as negative correlation. So as X is increasing, Y is also increasing, then we call it as positive relation. So in our old math terminology, so we call it as inverse proportionality, we call it as direct proportionality. If X is inversely proportional to Y, as X is increasing, so Y going to decrease proportionately. So we call it as inverse proportionality. As X is increasing, if Y is also increasing, then we call it as a direct proportionality, or we call it as positive correlationship. So when we are looking into negative or a positive, there need to be, or there must be, a correlation. So without a correlation, we can't build any of our linear regression models, and even we may not get a proper set of accuracy, right? So in correlationship, in case of X and Y, if the plot is something like this, we call this kind of plot as a scatter plot. We call it as scatter, SCATTR, scatter plot. So if the scatter plot is showing a pattern, then it is negative. If it is showing a pattern towards upwards, it is a positive. And if there is no pattern, we call it as no correlationship. So this is how we would be picking it. And in order to calculate any correlationship, you need to check there's three assumptions of correlationship. One is the data need to be either, majorly the data need to be numeric. So either it need to be interval, or it need to be a ratio level. Means the data can be either in numbers, whole numbers, or it can be in this one as well. Like you can take it like a ratio level or in a percentage level. So there need to be a correlation. And next thing is both the data need to be linearly related, and both the data need to be bivariate normally distributed. You can see here, so when I'm plotting a data between two columns, so one is you can see based on the box plot, you can say whether it is normally distributed or not. But when you're looking into it, this is not exactly, a bit of skewness is present. Even for this, a bit of skewness is present. So but in order to do our analysis, we are accepting it and we are doing it. So bivariate normal distribution, in the sense whatever the column you are checking for a correlation, both the things need to be correlated, need to be normally distributed, and as well as they need to be linearly related. If any of these assumptions are not going into the consideration, so we can't expect a better correlationship with our models. So in order to get a better correlationship, one of the very important thing, or one of the very important thing, is nothing but going with which is nothing, we need to we need to check the correlation. So how to check the correlation and how exactly the values are ranging, you can have a look over it. So this is how the correlation is segregated. If the value is ranging between 0 to 0.19, we call it as very weak correlation. So if your correlation is ranging between 0.39 to 0.20 to 0.39, we call it as weak correlationship. So in case if the same way, if your correlation is ranging between 0.4 to 0.59, we call it as moderate correlationship. If it is ranging between 0.6 to 0.79, we call it as strong correlationship. If it is ranging between 0.8 to 0.1 to 1, not 0.1 to 1, we call it as very strong correlationship. And in order to calculate or to measure this, we use a value called as, we measure it with a variable r, small r. We call it as correlation coefficient, which is indicated by small r. And you can see here, this is the equation of your correlation coefficient. You can see r equal to n is nothing but number of rows. So say summation x into y, you are multiplying x into y and you are summing it, minus sigma x into sigma y divided by square root of n sigma x square minus sigma x whole square, and n sigma y square minus sigma y whole square. So by using this equation, we are able to check, or we are able to calculate the particular R correlation coefficient value. This is how we would be working on. And one of the major important thing is always we need to get what exactly the 0.1 or 0.79 is. So if there is 100% of data, only 40 to 49%, 59% of data are correlated, and the rest of the data is not correlated. So at least if the data is correlated from 40% to 59%, we call it as a moderate correlation. If the level is more like 60 to 79, we call it as strong correlationship. If the limit is somewhere around 0.8 to 0.1, sorry, 8 to 1, in the sense 100%, we call it as very strong correlationship. So correlation is one of the very important parameter for your model accuracy. So let us see how exactly how to check the correlationship in our Python, in our R programming. So let me import the data. I just want to use empty cards. So I'm using inbuilt data set. I want to view my data set of empty cards. So this is the data what I have. I want to, the problem statement is, let me go with a simple problem statement. So top two-wheeler manufacturing company, or we can say like, so top four-wheeler manufacturing company want to reduce R and D charges. So if they are able to identify miles per gallon based on horsepower before building a prototype, they can save nearly 40% of R&D, right? So nearly they can save 40% of R&D. So they are planning to apply machine learning. So the major plan is they want to apply machine learning. Why? In the sense they want to go with 40% of R&D, so they are planning to apply machine learning for that. So for this reason, what they are able to work on here is, so I want to check the very first stage is nothing but correlationship. So here, what is the input? Let me check first input. I know the equation, simple linear regression. So what is the equation of a simple linear regression? Y equal to mx plus c, where y equal to miles per gallon and x equal to horsepower. So if anyone gives horsepower, they need to tell what is the miles per gallon for a particular vehicle. So where miles per gallon is a continuous data, so I picked the simple linear, and even in the problem statement, they clearly demonstrated that. So we want to make a statement about miles per gallon based on horsepower. So I picked simple linear regression model where y equal to mx plus c, where y is miles per gallon and x is horsepower. So, but I need to check correlation between miles per gallon and this. So I'm using plot of empty cars dollar miles per gallon, comma, empty cars dollar horsepower. So here we go. This is the plot what I'm able to see. Let you can see the plot. So it is negatively correlated as your miles per gallon is increasing. In order to increase a miles per gallon, so you want to decrease your particular horsepower. If you're unable to decrease your horsepower, your miles per gallon may not be great, right? So what we are trying to do here is, I want to check even correlation core of empty cars dollar miles per gallon, comma, empty cars dollar horsepower. So which is the correlation coefficient is minus 0.7761. So you can see here there is a correlation, empty cars miles per gallon, there is a negative correlation. But let me go back to material. So if it is between 0.6 to 0.79, we call it as a strong. So we can demonstrate in this particular analysis where correlation coefficient R is equal to minus 0.77, and which is a strong correlation, right? Perfect. So I'm able to see there is a very strong correlationship. And now I want to build a model. So building linear regression model. So here, what are the known parameters? So where y and x are known parameters, if we are able to identify, so m and c, then we can calculate y using RHS, right hand side, right? So for that reason, I'm using a model. I want to build a linear regression model. So I'm calling it as training. So in the training phase, so where model equal to LM is nothing but your linear model. So empty cars, dollar miles per gallon, your output compared with empty cars, dollar horsepower, right? So in the training phase, what is the major deliverable? So major deliverable of linear regression is to identify right slope and intercept value, right? So let me print it model. So you got the right slope and your intercept value. This is your slope, this is your slope, and this is your intercept value. I need to form an equation, form equation using model output. So where mpg underscore new equal to, so or you can use equal to. So what is the equation? So y equal to mx plus c, m into horsepower plus c. So mpg underscore n equal to where m is like minus 0.06823 into horsepower plus, so 30.09886 is the equation. But I'm not sure whether it is working or not, so I want to test it. Testing. So mpg underscore n, let me go back to empty cards. Here I can see already the miles per gallon is 21, and here the horsepower is 110. Let me test it. So for 110 horsepower, the miles per gallon, for 110 horsepower, mpg equal to 21. So let me you calculate new mpg underscore n, where mpg underscore n equal to, let me copy this and multiplication 110. So let me print what is the new miles per gallon. It is 22.59, right? So here error is nothing but, so error equal to mpg minus What is MPG? 21 minus 22.59. So we can say error equal to actual minus predicted. So where error equal to, so actual is 21 minus 22.59. So there is an error of minus 1.59 is the overall error of our model. So this is how we can write a simple linear regression model using our R programming. But how exactly our linear regression, or here the command LM is nothing but linear model, right? So by using this particular LM command, we are able to calculate M value and the C value, and we are able to form the equation. So if the quality of the slope and intercept are purely dependent on the quality of the slope and intercept are purely dependent on the correlationship between input and the output. In case if the correlation is not good, so your slope and your intercept value going to be pretty inaccurate. So in order to get a better accurate slope value and to get a better accurate intercept value, one of the very first thing we want to do is we need to get a properly correlated data, or in a simple line we need to get a proper data. In case if the data is not clear or if the data is not good, you may not be able to get a proper slope and the intercept values, right? Now what is the math behind getting this particular slope value and getting this intercept value? Let's work on it. So let me go back to my particular material. So in order to calculate slope and intercept, so here we go, these are the equations. So the very first step we have is ordinary least square method, OLS. So from that we are able to calculate it. So the equation of M is nothing but summation xi minus x bar, where x bar is nothing but mean of x, and yi minus y bar divided by xi minus x bar whole square. By using this, you are able to calculate the slope value. After getting the slope value, by substituting them into y bar, mean of y column, and x bar, mean of x column. So, and you calculated m from this equation. If you substitute it, you would be getting the b value, which is nothing but we call it as intercept, right? So after calculating the particular mean and after calculating the particular intercept b, so what we do is we plot a graph between y actual and we plot a graph between y predicted. So we are plotting various number of points, and after plotting various number of points we are drawing multiple fitted lines. So until we pass this particular fitted line across all the data points, so we rotate this particular process. You can see here that it is like second iteration or a third iteration or a fourth iteration. In this way we are doing it multiple times. So once we are able to see a better fit, like when we are able to get a least amount of residual, so this is your actual line and these are your residual points. So the perpendicular distance between your fitted line towards the point, we call it as residual. Until we get a least amount of error or a least squared error, so where exactly at which iteration we are able to get a least amount of error, we call that point as final best fit, or we call it as goodness of fit, right? So this is the process how exactly happens within your particular your OLS technique, or this is how your LM command going to work here. You can see this. So when you're looking even into the scripting, that's what we done. We got the particular slope and the intercept value, right? Until we get a better slope and the intercept value, we try to tune the particular algorithm. So in case if it is unable to provide us with a proper amount of values, or if it is unable to provide us with an inaccurate, if there is a huge amount of error, the problem going to be with our particular we can say with our coefficient, the slope and intercept, and the slope and intercept are getting diluted because of your correlationship between x and between the y parameters. So now let's try with even a multiple linear regression model, and even some cases let me see what exactly I want to measure. So just a single value, I calculated error only for one row, but I don't want to do it for only one row. I want to calculate it for error for entire data set. So how exactly we can calculate? We can simply type summary of model. So by typing it, you are able to see you got R squared. So this is your R squared. I explain you in next e-learning where what is meant by multiple R squared, adjusted R squared and all this. So you can see the R squared value, which is 0.62, means your Y actual and the Y predicted, they are related only 60%, means there is no proper accuracy. So to say 100%, the R squared need to be 100, so that the accuracy of the model going to be pretty 100%. Here the model accuracy is not 100%, so getting 100% accuracy is one of the major requirement. So for that reason, so I want to improve the accuracy. Even I explained it to the client, hey, you can see here the particular X and Y are known parameters. And even I clearly said he want to make a statement about miles per gallon. So to reduce the 40% of R&D, but practically speaking, so mileage is not dependent only on horsepower. There are various parameters which are impacting our horsepower. So we thought of going with multiple linear regression model. There need to be more than one input parameter. So what I'm trying to do is, from this, I'm planning for multiple linear regression model. I'm not forming any equation now. You already know how to form it. So for that, again, model underscore multiple equal to lm of empty cars dollar miles per gallon compared with empty cars dollar horsepower, plus it is also interlinked with cylinder. It is also interlinked with displacement of an engine, plus empty cars dollar. It is interlinked with gear, number of gear. Let me run it and let me print the model underscore m. You can see there is an intercept and multiple coefficients. I want to see overall summary of the model, summary of model. So you can see here, even not model, it is model underscore m. If I look into model underscore m, you can see there is an accuracy of 77%. The accuracy improved. So by using your particular all the columns, let me try with by trying with all the columns. So model underscore m1 equal to lm of empty cars dollar miles per gallon compared with full stop, and data equal to empty cars. So where full stop replaces rest of the column, so for that reason I used full stop rather than writing every column. You can use a full stop. So I want to check summary of model underscore m1. So you got 86% accuracy. It's a pretty good. I think by using all the input parameters, there is a very good accuracy. We can see it. So this is how we can check it. And let me see what is present inside this data. Let me click it. You got the coefficients, you got the residual value. So you can see the residual error is pretty low, like 2.65 is the overall residual error. And there is a pretty degrees of freedom of 21 degrees of freedom. You are able to see. I touch what exactly meant by degrees of freedom and all this when I'm doing evaluation metrics and all this. So overall model accuracy is 0.69 percentage. So even p-value, I would be touching all this when I'm evaluating. I'm not touching evaluation now. On the next e-learning I would be doing it. So this is how we can improve our model accuracy by adding more columns. So always we don't go with a simple linear. In majority of the real-time cases we go with a multiple linear regression model. So when we are getting into multiple linear regression model, always the accuracy going to be pretty good, but even some cases the accuracy may not be good due to the problem with your current data set, the correlation and all this kind of areas. So I want to check with, I checked with correlation, I looked into simple linear, I looked into multiple linear regression model. Now I want to check one more specific parameter, which is nothing but, let me go back. the assumptions. So there are various assumptions, means when we are starting with any of the linear regression model, there are a bunch of assumptions which we need to go with. Assumptions of linear regression model, right? It is same for either you're going with a simple or a multiple linear. The first assumption they state is, so data need to be linear. Data need to be linear. So if there is no linearity, you may not get a better slope value and a better intercept value. Second, there must be homoscedasticity and no hetero scarcity. So what is meant by homoscedasticity and heteroscedasticity is, if there is a pattern, if there is a pattern, we call it as homoscedasticity or homogeneous data. If the data is something like this, if there is no pattern, if there is no pattern like this, so we call it as heteroscedasticity or heterogeneous data. All right, there is no pattern. Here there is a pattern. So there must be homogeneous. If the data is not homogeneous, again, the particular slope and the intercept value is going to be pretty poor. And the next thing is, and the third assumption we are able to see is no auto regression. So what is meant by auto regression is, when you are going into any time series data, let's imagine every winter season there going to be more sales for sweaters. In every rainy season there going to be more sales for umbrellas. For every summer season there going to be more sales for our air conditioners. So when you're looking into these parameters, no need to go with any model building. I think there is a auto regression. So keep on happening the similar kind of events based on the time, based on the seasonality, and based on the cycle. So that's the reason when you're looking into any of the particular assumptions of a linear regression model, we need to be pretty clear that there should not be any auto correlation or auto regression. Why? In the sense, if there is auto regression, we can't build a proper machine learning model. And even linear regression is not required. If there is auto regression, there is no need of linear regression. Why? In the sense, with respect to time, we can make a certain statement. So is no the fourth point is nothing but no multicollinearity. What is meant by multicollinearity? So if there is a relationship between three columns or more than two columns, let's imagine sales is related with profit. Profit is related with expenses. Expenses is also related with some other thing like quantity. If all the four elements are correlated, so we can't go with multicollinearity. So if there is a multicollinearity, so the cause or if there is a problem in any one row or in any one cell, the entire data or entire values get impacted, means your correlation coefficient get impacted, right? So not only that, you were able to see a huge amount of error in your model. The slope and intercept value is going to be pretty inaccurate. So in order to overcome that issue, in case if there is any one error in any of the column, all the four columns going to impact it. So for that reason, we say no to our multicollinearity. So what exactly meant by multicollinearity is, for example, as sales is increasing, so if sales are 100, so let me write it down. So when sales is 100, profit is 10, and expenses are 90. So when sales are 200, profits is 20, expenses are 180. When your sales are 300, profits is 30 and expenses are 270. So in this way, when your sales and profits and expenses are improving, what is happening? So your sales and profits are correlated, profit and expenses are correlated, means A is equal to B is equal to C. So to make a statement about A, either we can use B or we can use C. So if we are using all the three, the change in any one may result a huge impact for A, right? So why to take a chance? For that reason, we say no to multicollinearity. If there is any column with high multicollinearity, we don't pick them. We say no to multicollinearity. And the fifth assumption we see is nothing but hash 5. So 0 residual mean across fitted line. So this is another fifth assumption. So the data need to be linear. There must be homo. There no two heteroscedasticity, no autoregression, no multicollinearity, and zero residual mean across fitted line. So let me show you, for example, all the points need to be in line, and if you're drawing a fitted line, everything need to stay on is getting connected. In case if there is any points not connected, the perpendicular distance between the point to this is nothing but we call it as residual, right? So we are saying there is no residual mean, there is no residual error. So they are saying there need to be a zero residual error. Even if there is a residuals like this, it gonna impact your slope value and it gonna impact your intercept value. So one of the preferred approach when you are getting into your linear regression is we need to make sure that all the assumptions are getting satisfied. In case if any of the assumptions are not satisfied, and if any of the assumptions are getting broken, so one of the major problem we are able to witness over here is the diluted slope value and a diluted intercept value. So one of the major deliverable of a linear regression model is always going to be the slope and the intercept value. If they are getting impacted, or if they are not working properly, or if they are not good, we are unable to build a linear regression model. So to get a right slope and intercept value, the first thing is correlation is important, and rest of the five things is they need to be linear, and they need to be homoscedasticity, and there is no autoregression, there is no multicollinearity, as well as there is no residual mean across fitted line. So these are overall five assumptions which we need to get satisfied in order to make a statement about our particular linear regression model. So when we are building any of the linear regression model, we need to make sure that all these things are getting satisfied. And based on this, we need to go with various evaluation metrics. There is, we need to check for residual error. We need to look into adjusted R squared. We need to look into multiple R squared. We need to check for degrees of freedom. We need to check for F statistics, P value, and all this. So on our next e-learning session, we look into how to check for all these parameters. And I'm sharing the script with you. You can practice it whenever you find the time. So even I provide you with an assignment, you can work on it. All right, I saved this linear, and even these are our assumption sheet. Even in the material, I can provide you with the material. In the material you have the assumptions, you can look into it, right? So this is how we check for linear regression majorly. And even on the next e-learning session, we look into the particular evaluation metrics of linear regression model, right? So when you're getting into, before getting into evaluation, make sure that you are very good at programming. And once you're good at programming, check for the correlation coefficient of determination. So R2 score, you can see here, I'm able to find R squared is nothing but, I call it as coefficient of determination. Either you can check for R squared, or some people call it as coefficient of determination, which is very important to check the model performance or the model behavior, right? So, well, thank you so much. See you on our next e-learning session. Thank you. Bye-bye.